So, introduction, energy in its various forms have become an essential commodity. Um, However, scarcity of the conventional energy technologies and challenges to harness alternative potential on the conservation or efficient or conservation measures. So you can see that in figure 2, Pakistan power sector. The peak demand in 2020 is 32,876 megawatt, and the net generation is 29,747 megawatt, and deficit power 3,129 megawatt. According to the Pakistan Economy Survey, that in 2020, the total installed capacity was 37,000 megawatt. However, Pakistan is still facing the energy crisis, despite having the energy. Despite having the energy is excess of the demand. In this condition, demand side management is suitable, where DSM program are employed to use available energy more efficiently without installing new transmission and generation infrastructure. And DSM is also prescribed rule through which energy conservation from peak hours to off peak hours to complete their needs to enhance the electric power sectors. And it is also significant when the available capacity is short and fuel cost is high. And this is a literature review. The term DSM due to the oil embargo imposed by the oil producing country in 1973. And there is different literatures. Energy management is one of the energy management is the most informative literature. Will cover all regions of energy management. And there is another literature which is proven including energy efficiency, demand response, and energy utilization. All these programs are applied in different leading countries to stabilize their power sector, and these same programs will apply to enhance the Pakistan electric power sector. The key research gap identified in this in different literature and these literatures lack of the effective implementation to achieve the DSM objectives. And this is a problem statement. The country's population is growing repeatedly, so the electric powers and the future energy would meet by developing the new power structure. But Pakistan is a developing country. Pakistan cannot be afforded. So Pakistan needs the energy efficiency and conservation techniques to achieve the objectives. And this is a research methodology. There are different energy modeling tools are used in this study. Low emission analysis platform tool is used. Is forecasting Pakistan energy demand. LEAP is widely used the energy environment modeling to generate the energy scenario, and these scenarios are the based on the accounting of how energy can be consumed, produced, and under the available prices, available technologies, and available resources. And LEAP model has the 4 demand modules. One is key assumption, and second is a demand module, and third is a transformation module, and fourth one is a resource module. In the key assumption module, data related to GDP, population, number of consumers, past consumption, number of household related data can be entered in the key assumption module. But and second one is a demand module. Sectorial electricity consumption can be entered, like domestic, commercial, agriculture, industrial, and others. And in the transformation module, energy generation of a power plants, like historical data of the power plants, installed capacity of the power plants, like historical production, and maximum availability and lifetime related data can be used. Based on the electric power sectors, Pakistan electric power sector, two scenarios are developed. One is business as usual scenario, and second is the demand side management scenario. Base year is 2020 and the target year is the 2050. And first scenario is a business as usual scenario, which is runs according to Pakistan power policies. And other scenario is a demand side management scenario, which is runs according to new strategies like energy efficiency and conservation techniques, measures, or potential saving. Like this in figure 4 mentioned their potential saving percentage, and a domestic 30%, industrial 25%, commercial 23%, agriculture 20%, and others around 7%. So these are, this can help to run the alternative scenarios. And the results and analysis demand projection. So below column shows the business as usual scenario, which runs according to the Pakistan power policies, and the red shows the demand side management scenario, which runs according to the new strategies. So the energy demand by business as usual scenario in the 2020 is 107.1 terawatt hour, and this these both. And the forecast in the India by 2050 is 530 terawatt hours, whereas the energy demand by DSM scenarios in the base year 2020 is the same like base year scenario 107.1 terawatt hours, and the forecast in the India are 403.7 terawatt hours. There is a big difference between the business and demand side management scenario, and DSM tends to result in a 24% decrease in the energy demand compared to the business and scenario by 2050. And this is the same for the comparison of the electricity generation by both scenarios. And the energy demand by business scenario in a base year by 2020 is 128.7 terawatt hours, and the India by 2050 is 631 terawatt hours. Whereas the demand side management scenario, energy demand by business scenario in the base year by 2020 is the same as business scenario 128.7 terawatt hours, and the demand side management scenario is a 447.7 terawatt hours. And there is also a big difference between the business in a comparison of the electricity generation by both scenarios. And DSM in comparison of the electricity generation, DSM tends to result in 29% decrease in energy demand compared to the business in user by 2050. And there is a conclusion. This area successfully modeled on the business area scenario and alternate scenario. The result shows that the alternate scenario are far better than the business area scenario, also known as the Pakistan power policy scenario, because the alternate scenario gives an alternative path to overcome the ongoing electricity crisis of the Pakistan by reducing the imported fuels, imported resources, like, and this is questions are welcome. Thank you.
So thank you. Please go to your conclusions now. You are mentioning 143% increase by 2020. So it is a mistake because 2020 has already passed.
Sir, maybe this is a mistake, but I find out these comparison.
Maybe you wanted to write 2050 or something. So, geez. Okay. Secondly, did you develop some model or just this evaluation has been performed using some software?
Sir, this is a model.
You use some equations there must be some equations in the model. There should be some mathematical model.
No, sir. This is a simulation-based model. Low emission
Already
leaf
existing
model.
tool. This, you
Yeah,
done
leaf
existing
tool is used in this.
And where did you get the data that was input to that model?
Sir, I also suggest. I also discuss in between that there is a 4 module of leap SD 4 modules, key assumption module.
No, I'm talking about the data. Maybe you can note these suggestions and you can incorporate in your
Sir,
paper.
there are different sources of the can we collect the data like Pakistan Economy Survey, Energy Yearbooks, and there is World Energy Outlook or World Bank data or Asian Development Bank, and also available literature reviews. सर सेक्टोरियल इलेक्ट्रिसिटी कंजप्शन यूज की है, जीडीपी यूज की है, एंड नंबर ऑफ कंज्यूमर्स यूज किए हैं, एंड ट्रांसफॉर्मेशन मॉड्यूल में इलेक्ट्रिसिटी जनरेशन रिलेटेड लाइक हिस्ट्रिकल डेटा यूज किया, प्रेडिक्शन यूज की है, इन गीगावाट वर्स इन इंस्टॉल्ड कैपेसिटी यूज की है, एंड लाइफ टाइम पावर प्लांट की यूज की है.
ठीक है, थैंक यू. Thank you. Thank you so much.
Thank you all for your presentations. I would now request Mr. Ayaz Mirza, who is the Vice President of IEP, and Mr. Farooq Arbi, who is the Secretary of IEP Karachi Sector, to please come up for the award distribution ceremony. I would now like to call Ms. Dure Jabin to collect her award. I now request Dr. Aslam Bhatt to come and collect her this award. Now I request Mr. Mohammad Zahid to come up and collect the reward. I now request Mr. Mohammad Awais Akhtar to come and collect his reward. I now request Mr. Sharjeel to come and collect the reward. I now request Mr. Mazhar Ali to come and collect the reward. Thank you, sir. Thank you. Congratulations to all the participants for receiving their shields and certificates. Ladies and gentlemen, we now enter our lunch and a namaz break. The technical session will resume in about 1 hour. Thank you.
Recording. Recording in
missing pick,
progress.
missing ends, colors, oil stains, stitches issues. So some of these are more frequent and some are rare, but we are planning to actually classify all of these with the help of sample images. I'm sure you all are aware of how deep learning works. Basically, what we do is that we collect hundreds and thousands of images of the object which we are going to inspect. And then we classify those images into good images and bad images. And then in the bad images, we annotate the areas which we believe are faulty. And then all these images are then given to a deep learning algorithm program. And that actually then develops a deep learning model. And that model is then used in real time to actually perform the inference or classification. So the first step in every project is deep learning project is to collect images, thousands of images, and then manually inspect them and then classify them into good and bad images. And bad images are then again further classified into the area where the fault is. So we have to annotate the areas where the faults are. So these are the faults which generally occur in fabric: missing picks, disorders in weaving. So these are like holes in the fabric, a ladder. Different type of faults are there, but not all faults occur in all type of fabrics. So this is a trial version of the system. We deployed a camera with CPU, appropriate CPU with optics. So this is the terry towel which falls from the upper floor. After manufacturing, it is then collected on the spool. So we install a camera here, which actually takes images and then classify the images and then annotates the faulty areas. Another view of the camera. So this is the confusion matrix we obtained after our learning. Only 6 and 7 are the, you can say, wrongly classified or unclassified. The rest are properly classified. So these are the results of the actual real-time inference of the system. This is the fault that the system detected. It's called missing pick. This is also a fault detected by the system, a hanging thread. This is called a locha, a jumbled threads, oil stain, a fiber ball here and there. These are automatically captured and annotated. A cut-on pile. So these are the defects that the system has so far been able to easily identify and classify. The next application is blister fill inspection system. This is related to pharmaceutical manufacturing. Blisters are, as you all are aware, the older people are much aware of the medicines. So there are different type of packaging, LUPVC and LULU. LUPVC is when we have PVC on one side of one face of the blister, and LULU when we have aluminum on both sides. So you don't see anything after it is packed. So the right location where we want to check the system is when it is not packed yet. It is not sealed yet. So this is a general layout of a blister forming machine. There are 2 foils, base foil and top foil. Here the tablets are inserted, and it is at this location that just before sealing that we place a camera and we carry out real-time images, and their processing is carried out. And if there is a fault in the blister, it is rejected at this location. After being cut from the main base, it is rejected. This is a picture of one of the systems we recently installed. We check the quantity of the tablets, their size, area, perimeter, width, length, shape, location. All these parameters of individual tablets are inspected. And if any of these parameter is beyond the acceptable range, the tablet is declared faulty and it is then rejected off the line. These are some of the rejections we received from the system. You see, this is a broken tablet. Then a broken tablet with its another piece. Tablet with a black stain. This is very difficult to capture, but we have developed special algorithms, alhamdulillah, which easily detect such faults. Then in terms of capsule, there are different faults because a capsule is an assembly of a shell and a cap. So there are multiple faults. A cap alone, a shell alone, and this is a special fault which occurs very rare. A shell with two caps. One cap from another capsule dislodged from there and lodged itself onto this capsule. So this capsule has two caps. So our system actually identifies all these faults and then removes the faulty blister from the production line. These are some of the specifications. Time ho gaya, I think. Thank you. Any question? No questions. Ji.
Thank you. Thank you, sir, for a very informative talk. मेरी मालूमात कंप्यूटर AI के बारे में थोड़ी कम है. मैं थोड़ी सी अपनी क्यूरीज क्लियर करना चाहता हूँ. आपने जो एक सर्कल डायग्राम शो की जिसमें आपने AI का सबसेट शो किया, मशीन लर्निंग को, उसका सबसेट डीप लर्निंग को. आप मशीन विजन जो आप डिस्कस कर रहे थे, जिसको हम देख रहे हैं कि इट इज सम सॉर्ट ऑफ रिप्लेसमेंट ऑफ सेंसिंग डिवाइसेस. मैं इसको इस तरीके से देखता हूं. ठीक है सर. तो ये जो मशीन विजन है वो ये जो तीनों टूल्स आपने बताए हैं इसको इस्तेमाल करेगा?
जी. Machine vision is basically a method of taking the raw data, raw input. सही है. So once you have raw images, you can process them with traditional machine vision techniques, which are image processing, like blob analysis, filters, open filter, closed filter.
So what about the computational efficiency? Real time में कितना delay create होता है? I don't have idea कि
obviously that's very important. जो general methods हैं machine vision के, जिन्हें optical methods आप कहते हैं, which do not include any AI or deep learning or machine learning, वो we actually target for an inspection within 30-40 milliseconds. In general production industry, if it is more than this, तो वो फिर real time नहीं रहती, because the faults have to be removed as well. लेकिन जब आप machine learning या deep learning employ करते हैं, तो then this time increases from 200 to 300 or 400 milliseconds.
So, for those projects which you have done till now, what type of cameras have you used?
Generally, the latest we have used for blister inspection is 6 megapixel. Or as far as interface is concerned, we use Gigi interface cameras. Gigi means कि उनका जो throughput है, that is in gigabits. So Gigi interface इतना interface होता है optical cameras, general cameras. लेकिन they have higher resolution and they have higher throughput and better bit depth. We generally use 16-bit depth cameras.
Thank you.
Thank you. Thank you. Ji. Not the same thing. If you can program it, then you don't need to use deep learning. If it is programmable, if you can identify the fault by just simple image processing, like blob analysis, segmentation, and then filtration, then it is overkill to use deep learning. जी हाँ, लेकिन इसके बावजूद भी जो ट्रेडिशनल टेक्निक्स हैं मशीन विजन की, they are cheaper they can easily be implemented in real time with small processors. सही है? तो इसलिए we try to solve the problems with traditional methods. If traditional methods fail, you cannot quantify the fault, you cannot measure the fault beforehand, you cannot have clear-cut algorithm to identify the fault, then you have to go for CNN or DNN. Accuracy जो है वो ऑप्टिकल मेथड्स में ज्यादा है, जो ट्रेडिशनल ऑप्टिकल इंस्पेक्शन मेथड्स हैं उनमें ज्यादा है. इसलिए मतलब जैसे मैंने बताया, आप ग्लोब एनालिसिस है, सेगमेंटेशंस हैं, आप फिल्ट्रेशन करें, आप सेगमेंटेशन करें, ऑब्जेक्ट्स को आइडेंटिफाई करें, देन उसकी कैरेक्टरिस्टिक्स मेजर करें, दे आर मोर एक्यूरेट. बट दे कैन नॉट हैंडल unknown type of cases and large type of cases. They consume less time. They consume less time. The traditional methods consume less time. इसलिए कि जो डीप लर्निंग के जो मॉडल्स हैं वो जैसे मैं बताया 300, 400, 500 मिलीसेकंड्स तक लेते हैं. Unless you employ very high compute power GPUs, they consume close to half a second or 1 second. जबकि जो ट्रेडिशनल मेथड्स हैं जिनमें आप सिंपल, आजकल तो लोग जानते हैं ओपन सीवी बहुत कॉमन है, ओपन सीवी आप यूज कर सकते हैं, तो वो मिली सेकेंड्स में रिजल्ट दे देते हैं. 30 मिली सेकेंड, 40 मिली सेकेंड इसमें रिजल्ट मिल जाते हैं. किसके लिए? फॉर डीप लर्निंग योलो 5 यूज को, या ये जरा पहले का है थोड़ा सा, लेकिन ये कि उसमें योलो यूज हुई है. तो लेकिन ये कि जो ट्रेडिशनल प्रोग्राम्स हैं, जैसे मैंने ब्लिस्टर इंस्पेक्शन दिखाया, इसमें मशीन लर्निंग नहीं है. ये फिर ओपन सीवी या इस तरह की कोई और एमगू सीवी या कोई और इस तरह ओपन सीवी शार्प, ये जो इनके जो रूटीन्स हैं इसको यूज करके की हुई है. हाँ, इससे तो बनाना पड़ेगा ना, ट्रेनिंग सेट तो बनाएंगे, ट्रेनिंग सेट बनाएंगे, फिर तकरीबन 2000 इमेजेस यूज करके. कलेक्ट तो हमने बहुत ज्यादा किए थे, बट इट सिंस इट इज एट द ट्रायल स्टेज, तो हमने तकरीबन 2000 के करीब यूज किए. थैंक यू जी.
Thank you for those insights, sir. I would now like to call Mr. Mohammad Zahid from UET Taxila to present his paper on the design of dual band microstrip patch antenna for wireless local area network applications.
Assalamu alaikum. Today I am here to present one of my students' paper that is related to antenna electromagnetic field theory. This one is a third paper that is related to antenna. First of all, I want to clear about this third paper, why we are choosing antennas and working on the antennas in the different frequency bands. This one is dual band antenna for WLAN, wireless local area network. In the current situation, in the current scenario, we are working all the devices, handheld devices that are operating on 2.45 gigahertz, that is ISM band recommended by the FCC, or we can say the regulatory body, that is ITUT. And the next band is 5.8 gigahertz, that is a proposed future band. A lot of equipments that are being currently using the 5.8 gigahertz nowadays. But In the future generation, we need more data rate, high data rate, with respect to time, with respect to connectivity. More number of users are being connected to each other. A single person have more than 3 to 4 to 5 devices. So that's why our main aim to design a WLAN antenna for dual band, or the future aim is to tri-band. So this one is this is the outline, same like that. I will follow from the problem statement, and then the introduction of some literature review, then the design of the proposed antenna, final design, some results discussion, and finally I will conclude. This is a problem statement, like the same problem statement that I discussed about with respect to time. We're moving to the higher data rate. That is what that will be 4.9 and 6.8. These are not the final design bands for the frequency or the allocated band. In short, we can say these bands are not allocated currently for the future WLAN applications. These are the unlicensed bands that in future they will be licensed. The current licensed bands are 2.45 gigahertz, 5.8 gigahertz, 3.5 gigahertz, 2.45 and 5.8 gigahertz. These are two ISM bands. For the W band, WLAN band, there is 2.45, 3, 3.5, 4. These are the licensed band. But 4.9, 5, 6.9, 7, these are the unlicensed bands that will be licensed in future, we observe. These are the aims that what we want to do. We want to design an antenna with a compact size, a single antenna that can operate on the different frequencies as per our requirement. And the same antenna will utilize the electromagnetic spectrum. We have designed this antenna, the students have designed this antenna in HFSS simulation tool. And they use FR4 PCB sheet. Why we are using FR4 PCB sheet? These are the low cost, are the cheaper, and at the low frequencies they have low losses. The overall dimensions of the antenna is 17.8 and 16.89 square millimeter. The dual band capabilities were what good transmission capabilities, like these are the 4 steps by which we have started to design an antenna. The first one is to what we have to decide what to do. We want to design a WLAN antenna. For what applications? This is the WLAN. For what band? These are the bands, 4.9 and 6.7 gigahertz bands. And finally, we conclude like what our design antenna is simulation is efficient in terms of the simulation way. These are the 4 ways, like this is the literature review scenarios by which we have compared our design and antenna. The proposed design in this paper, in this presentation, is same like one of from the articles already published. The major addition in this design is there is a circular slot and the inverted U-shaped slot. These two inverted shaped slots are clearly presents the resonance as to different frequencies. The upper inverted circular slot is capable to get the desired band at 6.7 gigahertz. The lower inverted U-shaped slot in the field line that activates these 2 ears of the antenna for lower frequency bands. In the parametric analysis, I will discuss later about that. First of all, I want to highlight the lower band is what? Due to the inverted U-shaped slot, and the higher band is due to inverted C-shaped slot in the patch. These are the steps, different steps that we have followed. The first band was made Burbot inverted U-shaped slot that is groove in the fail line, and the second band was made by the cutting inverted C-shaped slot forward for the higher band. And we can, in the simulation tool, we can assume to be verify the results by surface current at the different resonant frequencies that we have done. The VSWR is the same results, same curve that we can verify from the S parameter and the reflection coefficient. We are getting the bandwidth. And in S parameters, we have to take the bandwidth with respect to different ranges, -10 dB or -6 dB. That is also equivalent to, in terms of VSWR, that is 3:1 or 2:1. If we are talking about the bandwidth is 2:1, that should be equivalent to the -10 dB reflection coefficient. At -10 dB reflection coefficient, why we are taking -10 dB? At -10 dB, there is a reflection of 10%. There is a reflection of 10% at -10 dB. And -6 dB, there will be a reflection of approximately 25%. So these bandwidths are varying with respect to the applications that what type of, we are unable to get the 100% accuracy in terms of simulation and the prototyping scenarios. So we are trying to get the results that would be approaching to the maximum efficiency. This is a current distribution by which we can see the lower band is due to this inverted U-shaped slot that is able to resonate the lower ears of the antenna, and the inverted C-shaped slot is able to resonate the antenna at the higher band. उधर से कर दे 15 स्लाइड पे करें. Okay, last two slides I will finally conclude. Like in this scenario, from the current distribution, we can observe and verify our results that we are getting the S parameters and the frequencies or not. By using the conventional mathematical modeling of the antenna, we will get the design of an antenna that will be more bigger than the current design. So okay, leave this. छोड़ दे. Okay, छोड़ दे. This antenna is actually the design of the dual band antenna is operating at the 4.7 and the 6.9. I think 4.7 and 6.9 gigahertz for future wireless WLAN applications, local area network applications. And if anybody wants to design an antenna using the different tools, they have to verify in terms of simulation, S parameters and VSWR. If their results are looks good, then you can verify by the same results by checking the current distribution of the antenna, which part of the antenna is resonating at which frequency. So that we will be able to in some case, we will be able to like compare our results before like going to the prototyping scenarios. The application of this antenna is for, as discussed in the title, this is for wireless local area network applications. This is all about the today's presentation by Band. Thank you. If anybody have a question, please, you may ask.
Now the house is open for the questions.
Sure.
House is open for the questions. Anybody from the audience?
HFSS, ANSYS. Sorry. Presentation again? Just a minute, please. Presentation. Ji. Which slide? Like in the they're not observer. These are the reflection coefficient that the curve shows at a certain frequency. That is shows that power is being reflected at certain range. Like we are getting taking the bandwidth in terms of minus 10 dB reflection coefficient. That shows at minus 10 dB reflection coefficient there is a 10% reflection in terms of dB. There is a bandwidth. The curve is like yes. Yes. Hmm. Next.
पहले उसको नॉर्मल खोले, उस स्लाइड को सिलेक्ट करके.
But normally next this one. So छोड़ दे. This one. This is a reflection coefficient. Like S11 shows in two-port network there will be 4 S parameters: S11, 122, 122. We are like using a single port, so we are getting S11. S11 is a reflection. The y-axis shows a reflection in dBs. Like if there is a reflection is minus 3 dB, if we are measuring at minus 3 dB, that in that case we are like assuming there is a 50% reflection. And minus 6 dB, there will be a 25% reflection. At minus 9 dB, there will be a 12.5%. So it is like to be assumed that minus 10. Sorry? Yeah, is equal to 1. Transmission plus reflection is equal to 100%. So हमारे जो इंटरेस्ट के जो बैंड्स हैं वो ये वाले दो हैं, लाइक 4.7 एंड 6.9, जो हम लाइक अचीव करना चाह रहे हैं. माइनस 10 dB पे देखा ना, वो कर्व डीपर जा रही है, नीचे जा रही है. तो देयर विल बी माइट बी पॉसिबल 0.01% रिफ्लेक्शन एट द रेजोनेंस फ्रीक्वेंसी. So please.
Okay. Actually, whenever it's just like a comment, whenever you are going to present a paper which is related to the engineering, you should at least produce the mathematical modeling which is behind what's going on through here, right?
Yes.
Just my comment, just my suggestion, because here we can't see any modeling that like which distribution of the noise you are being using. what is the distribution, whether it is Poisson distribution, it is Gaussian distribution, and so on and so forth. And the second thing is we don't know exactly what the S parameter, like you have to show us what the S parameter matrix is over here, like S11, the first row, first column, first row, second column, second row, first column, and second row, second column. Similarly, here we can't see, here we can't, like you can say that judge that what is going to change with a change in the certain parameters, right? And thirdly, whenever you're going to show about the literature review, you should show at least what the previous scientists have done in this particular field, which you haven't shown, unfortunately.
Sure.
So, I mean, like these are some of the comments, because here we are already confused about the things that what's going on. I mean, you have just put one legend with the red color, and what about this one? There's no detail. So, can you please, I mean, just explain this curve so that we can easily understand what's exactly going on? And thirdly, I mean, the final comment, what is the maximum power which is being transferred from the point A to the point B? I mean, from the transmission end to the reception end. Have you calculated that one? Thank you.
Yes. At start, I will like elaborate. The first point is we are going to design an antenna in our simulation software. There are different ways to verify the results are like accurate or not. In the way of like if we are using the mathematical modeling, there is a mathematical modeling equations, patch length with dimensions, and the constant time like antenna theory book. There is a one way. The second way is to like we are going to design the antenna and we have to prototype that antenna. We will compare that these results are these okay or not. The third way is to compare the results of these antenna is equivalent modeling. Actually, the problem is this is the project for the undergraduate students they have done so far before submitting the final reports. And in the last like presentation in the previous session, session 5, we also discussed about this same scenario. The like in the last session, the audience also asked about the prototyping. Like the students also had prototype, and we have verified the results. The issue is we have done with the paper and the submission in the month of May, and they have done all the like the question and that you are like asking about the verification of the results. We have done in the month of like end of the June and the start of the July. So that's it. And I requested to the group admin and the WhatsApp like conference secretary. He allowed me to like update the paper before publication. Like we will add these results later on. And do you have any question?
I mean, these are just my comments. I mean, if you're
Yeah, I know about that.
it's okay. If you're going to say that these are the preliminary results,
Yeah,
that's okay. But I mean, just for in the future case, we should at least produce the things which are up to date. No, it's not about sorry. It's just
I'm like saying
you,
sure we will do this.
No, it's okay. Thank you.
No problem.
Thank you.
Anybody?
Other questions?
Okay, thank you.
I would now like to call Dr. Tala Ahmed Khan from Beria University to please come and present his paper on the machine learning based optimal control for upper extremity rehabilitation robots.
First of all, respected faculty members and dear students, Assalamu alaikum wa rahmatullahi wa barakatuhu. So today I'm going to present my research paper. Actually, the co-authors are Dr. Kamran, Morif Khan, Dr. Fan, and Dr. Sudarspi. So basically, the research paper is a review paper. If I can explain you in a very easy way. So the engineering applications of the artificial intelligence or machine learning, that is basically the area. So in the engineering application, we have focused the robotics, and in that robotics, the rehabilitation robots. So we can proceed from here. So, exhaustive literature review reveals that clinical and misfortune events and traffic disasters may lead towards the brain hemorrhage, as well as the spinal cord injuries and some other broken uh, legs and some loss of the cognitive skills as well. So, the clinical studies involving rehabilitation robotics have supported in making devices for the treatment of stroke and spinal cord injuries and the patients. और ये जो रिहेबिलिटेशन रोबोट्स अवेलेबल हैं, जाहिर है कि जी ट्रेडिशनल दीज आर द अवेलेबल, बट their optimized and precise control was robustly needed. So that's why AI and machine learning algorithms was needed. Another term in the literature review, which was mainly focused, that is the exoskeleton devices that can be categorized into two types. Number one is the ungrounded, and number two is the grounded. So ungrounded are those that we can easily be understand that those devices which can easily be worn by any patient in the upper extremity. And in the grounded, we can take as an example that the grounded are acknowledged as a kind of devices have a larger workspace and enables the subject to perform more naturalistic movements. So we have done research in the ungrounded robots. Problem statement. So from the exhaustive literature review, there were some problems which were focused and highlighted in the traditional researches by the researchers. Number one is that the noise in the robotic systems, unwanted noise was there in the non-linearities and uncertainties was found in the dynamic models. So the disturbances was need to be minimized. And another thing is that if we increase the number of the degree of the freedom, so all of the engineering students, they must know about the DUF. So complexity also increases. Another problem statement was highlighted that the controller design of that particular device or upper extremity rehabilitation robot, and overshoot, damping and under damping problems was highlighted. Optimal controller parameters which could eliminate the undesired effects. So the controller's parameters, the appropriate selection of the parameters of the controllers was very necessary. Therefore, there is a need for the robust, reliable, and precise control system with minimum overshoot and steady state error in all the machine learning based rehabilitation robots. So that is the problem in the rehabilitation robots. For the optimal results, AI and machine learning robust algorithm was suggested and needed. Research scope. The research at the study focuses on the analysis and the implementation of control technique to achieve stable, reliable, and highly precise control. The research is focused on the passive type rehabilitation, during which the robot fully assists the patient to perform the rehabilitation exercises. इसमें physiotherapy की कुछ exercises और physiotherapy machines भी include हो सकती हैं. Some of the existing approaches which were found almost in all the researches and all the research papers, that is the electrical stimulation for the treatment of the hemipresses. Cortical stimulation is just like you need to wear on the brain to measure the EEG signals, electroencephalogram signals, and it is very complex to measure these signals and classify that signals. And another is MCIT, modified constant induced therapy, in which an intensive motor practice that consists of restricting the use of affected limb and forcing the subject to use impaired limb. And then the motor imagery, a process of imagining the movement of the impaired limb, a practice which activates some motor areas of the brain and some muscles as if the subject is actually performing an activity. And the motor imagery is especially in those cases when the blood flow stops over there and some of the methylcobalamin values decrease and there is no power from the behind from the brain. The brain signals stops working over there. So these rehabilitation techniques was suggested. These are some images which have been taken from the literature review, that these kind of the rehabilitation robots for the optimization of the upper extremity optimal control rehabilitation robots can be used and can be applied and have been applied. These are the upper extremity movements like in shoulder abduction, and another one is the external internal rotation, flexation of that particular right hand that you can move upward and downward, and it's all about the wrist, elbow, and elbow. And another research was found that there are some veins which can be pinched by the spinal cord injury as well. So the blood flow stops over there, and that may lead towards the paralysis. So in those cases, the rehabilitation robots have been suggested in medical applications of the robots. Range of motions have been defined, which have been shown by the shoulder, elbow, and wrist. In those degrees, there can be an extension. That is the mechanical structure which have been proposed by us, but that does not related to that research, because in that research we have only done that the review and some comparative analysis of the artificial intelligence algorithm. These are the basically optimization techniques for the controlling parameters. And if we see the first one, that is the Ziegler, Nicholas, and fuzzy decision making, that is the traditional approach which have been used to optimize that. So you can see that graph. It has achieved the 87% accuracy. And in the second one, in the 2004, the paper was published in which particle swarm optimization (PSO) was adopted and applied on that particular data set. So in the PSO performed was compared with the genetic algorithm, and it performed better than the genetic algorithm, and it produced around 93.07%. While optimizing the rehabilitation robots. And in the 2022, the PID controller was optimized by using the artificial bee colony ABC algorithm. And again, artificial bee colony ABC produced better results than the PSO by using in AVR systems. In 2014, again, PSO optimization was performed to tune the PID controllers, to tune the PID parameters. And the domain was 2DOF rehabilitation robot was basically optimized, and they achieved the again the better efficiency for that. So into 2011, again PSO was implemented. In 2013, neural network was used in this study as a controller, and again these basically these are the techniques which has been shown as a summary, but there are so many other techniques, and most of the techniques has been applied for the optimization they have used the PSO. So literature review revealed that for the optimization algorithm, the state of the algorithm and the state of the art of the algorithm, PSO can be acknowledged as the better optimization algorithm. So what we have done in the future research, because in that research we have only done the comparative analysis, we have done the review, so that to determine the which one is the better optimization algorithm to tune the PID controller for the rehabilitation robot cases, or in the application of the rehabilitation robot. So in the PSO, what we have done, first initially we have taken some state of the art algorithms, PSO, Firefly, ant colony, artificial bee colony, and Ziegler-Nicholas. Actually, why we have taken these one? Because the exhaustive literature review revealed that most of the researchers showed that PSO, ABC, and the Firefly have the better results compared to the other existing approaches in optimizing the PID tuning parameters. So we have taken the standard parameters for that. But when we have taken the standard parameters, sometime in that getting the results, there were some mistakes in the results which were found. So we need to select the appropriate parameters. So again, the appropriate selection of the parameters was very necessary to get the and to achieve the better results. So basically, PSO implementation, every algorithm has its cost function and objective function, and our motive and objective was to minimize the error, the absolute error, the integral error, and the mean square error. So the implementation of that PSO, in that case, we can see have a objective function over here. This is the function. In PSO, we do have two parameters like the particle velocity and the particle position. And easily we can understand that if we find the better velocity and the better position, it updates by itself and get the optimal values by self-healing process. So basically you can see that position of individual particles updated as follows. So particle position is the xi of key, that is the initial position, and that is updated with the particle velocity. So the initial particle is updated with the better velocity and then updated in the cost function. And you can have a look over there, that C1 and C2. So C1 and C2 cognitive and social parameters, usually the researchers have taken the standard values for that, but you can change that according to the results if you want to tune in. And R1 and R2, basically these are the random numbers which may be taken as the between the 0 and 1. So this was the implementation of the particle swarm optimization to optimize the PID parameters. Okay, so the comparative study was carried out with our different cost functions. And you can have a look over here that number one is the integral squared error, ISE, integral absolute error, IAE, and integral time squared error, ITSE, and number 4 is the integral time absolute error. So these 4 functions, cost functions, was designed and mathematically incorporated by using the PSO, as well as by using some traditional approach like Ziegler-Nicholas, and we have used the ANN built-in tool as well. And after the results was revealed that the ABC again and the PSO have performed better than the existing approaches, like the state-of-the-art of the algorithm Firefly, better than the Firefly PSO, and again R&B colony performed better. So these were the cost functions. These were the results which have been obtained on the MATLAB, is the lab view. So these are the readings over there. We can see that that is the cost function for the first one, the convergence graph using ISE, and number 2 is for the IAE, and number 3 is for the ITSE, the integral time squared error, and number 4 is the ITAE. So these 4 algorithms, PSO, Firefly, and Ant colony and Ant B colony, was applied over here. And the graphical illustration and analysis shows that the errors was minimized drastically by the particle swarm optimization and the Ant B colony. So that was the review, and that was the literature review, and these are the some references from these paper, and the research has been shown over here. Thank you, and if you have any questions, please ask.
Thank you. Overall, it was a good presentation, and in-depth results were shown here. House is open for the questions. Anybody?
Overall, very good presentation. Actually, you mentioned some percentage that, for example, fuzzy is giving you 82% and the PSO 92%, and likewise. So I have just concerned that means the objective functions, the input parameters, so all they have the same values. On that basis, you are saying that fuzzy is better is at 82%, and then PSO is at 92%, and likewise.
Okay, yes, sir, I got your point. But to be very honest, it varied, because in that fuzzy one, the rehabilitation robot was 2DOF. And in other research which you're talking about, then the PSO, that was more than 2DOF and 3DOF and 5DOF. So, but again, the application was the same. And that research paper showed that 82.07 was for the 2 degree of freedom rehabilitation robot. And if you're talking about the PSO, so that was not for the 2DOF, it's more than 2DOF. So slightly variations in that technical parameters that you're talking about, that's not the completely the exactly the same, but it varied.
Okay, thank you.
Thank you.
Excuse me. So, I have a question. Are you familiar with the confusion matrix?
Yes.
You talk about like errors, blah blah. So, are you familiar with about confusion matrix? What is confusion matrix? and how to calculate accuracy, precision.
If you are asking an question related to this, so it is about optimization and regression. And in the classification, we do have the confusion matrix, and we can calculate the TPR and the FPR and period it diagonally. Okay, so we in that case, I'm getting your point. You are asking that where is the confusion matrix, but we have not done the classification over here. We have done the optimization. So in the regression, we don't calculate the basically confusion matrix. We calculate the basically cost functions and the objective function, that is basically the graphical analysis and the illustration, which shows you that you have got your stochastic gradient minimal, which you want to optimize.
Anyways, you have to calculate error, right? So how do you say your error is less?
Your error
less.
is
Yeah.
less.
How can you say your model is very precise?
Yeah, because we have done the comparative analysis with the state-of-the-art algorithms.
There is any formula?
What kind of informal?
There's any formula to justify
Yeah,
your model is okay?
there are formulas for calculating the mean absolute error, like root mean square error. And if we can have a very simple example that
this is a statistical technique, right?
Sorry?
This is a statistical technique.
Yes, this is the statistical analysis.
Yep.
Okay. So these are the formulas to use the errors. Now that errors have also been calculated before our research. So we have what we have done. We have compared our results with the state of the algorithms to prove that the existing approach and the proposed approach is working better.
Is there any limitation in your algorithm or your
Yes,
statistical
yes,
model?
for sure, because it does not work in the real time. It is working on the off time. For that, we need a national instrument device, which can cost a lot. So that has also been applied for the funding. So that can be that is the only limitation.
What about ARIMA model?
Sorry,
ARIMA model, autoregressive and moving average. Why not integrate both models?
in our model, basically we have taken the 5 degree of freedom. First, we have calculated for the 3 degree of freedom, and then 5 degree of freedom. So these results are for the 3 degree of freedom, and the next phase for the 5 degree of freedom. So we increase the complexity step by step.
And by the way, how do you reduce the kernel's dimension?
Which dimension?
Like suppose y is a function of x1, x2 variables, right? So this non-linear function. So we try to linear function. As you said, linear integration.
Can you relate your question with this? I'm not getting your point that what type of the x1 and x2, because we have taken some PID controller parameters. We are not directly taking the dimensions. We are concerned
No,
about
dimensional I'm talking about. Like you said, regression, right? What is regression? Y is equal to a plus bx.
Regression
It's a linear equation.
Yeah, it's just like
I think
optimization.
we need to restrict our question to particular slide or any results. We are not
No,
going
actually,
to ask
the
general
regression is
questions
just like
here.
the optimization. So if you're asking that formula, again, every optimizer have its own objective and cost function. If we take an example of the SVM, support vector machine, popularly known as classifier, again, it's also a regression. It also performs the regression by changing some formula in that. So if you are asking that formula, we have shown that particular mathematical cost function of the PSO. And every algorithm does just like neural network, and just like feed forward propagation, back propagation, every algorithm has its own mathematical formula. I don't know what you're asking about concretely. I'm not getting your point related to that presentation.
It's simple linear regression and multi-linear regression.
It's simple optimization.
Thank you. We have limited time and closing ceremony will follow. So kindly restrict your questions. Only one questions. Anyone else? Or I give it to another session chair.
Hello. Very nice presentation. Actually, it is somehow related to my PhD work, which is related to optimization. Just the thing that I was curious about that, I mean, which data you're using for the, the results?
So actually, that data has been collected in the clinical research laboratory that is in China. So I just don't want to reveal that, but that's the conference paper. So that just for we have done a comprehensive research and literature review and just thing. The data and it has been performed in the research lab on the patients.
No, it's okay. If it is confidential, then it's okay. According to the ethical review.
Basically, it's a funded project, and some of the papers have been published in the MDPI Impact Factor and some other.
Okay.
So
One thing more that just you produce some of the results in the like having different algorithms. So may I know that are you going to run all the algorithms by yourself on the same data, or you have just taken out the results from other data and other algorithms or something else?
No. We have
This scenario is somehow confused because you said that this all is like the literature review, and at the next point, sir, you said that you have got some results. So I'm just curious about whether the same data and the different algorithms or different data, different algorithms or something.
Actually, paper. Thank you, sir. Actually, the paper is about the literature review. First, we have done the literature review just to determine which one is the best optimizer. So, if you are in this field, you know that the PSO and Firefly and some of the. So, after that, what we have done, we collected our data set and we applied these algorithms, and we've taken around 1 year. And then the data set was collected and has some discrepancies and missed values in that, and that was tuned and normalization was performed, and these are incorporated in the lab view, and these 4 are step by step was completed, and the results was calculated on the basis of that. And after that, the 4 one was run on a system which जिसको computational resources बहुत ज़्यादा required थी, तो it took around 2 to 3 days. So चारों को एक साथ रन करके we got that graphical illustrations and that.
Thank you very much, sir. Thank you.
Thank you. Any other questions? Thank you.
Thank you, sir, for that presentation. I would now like to call Mr. Arshad Chuftai from Mehtan University, Jamshoro, to come up and present his paper on the diagnosis of energy crisis of Pakistan and assessment of DSM as a viable solution.
Bismillahirrahmanirrahim. Honorable Chair, ladies and gentlemen, the topic is very unique but very relevant. And it is the talk of the day, talk of the town. There is an energy crisis, and a very severe one. Very severe. So when we finally come out and say that DSM is a viable solution, we have to look into the background. What is the background? We have got enough generation, so much so that we have got 40,000, more than 40,000 megawatts of transmission. All of you are engineers. Then we have got network more than 5 to 7,000 kilometers of transmission lines. We have got 500 kV transmission line. We have got 660 kV DC transmission line, and our consumer base is 36.5. I'm going into the final solution to find out. This is a sort of we are diagnosing, and we are coming to the analysis. What is the problem? Where is the problem? The problem is so severe that even our IMF agreement was very much connected with the energy crisis. They wanted to put Pakistan into a burden, then we should raise the tariff, we should recover the circular debt, and we should reduce the losses, and so a chain of events. This is a very, very interesting topic, my dear friends. Yeah. See, I told you that we have got power generation of 41,000 megawatt and around 6,000 kilometers of transmission lines. and 36 million of consumer base. You can say, still, with such a great growth in power sector, and particularly on the generation side, why we are facing this? Such a great crisis, load shedding all over the place, huge tariff, inflated bills, so on and so forth, and at the same time losses. And there's no awareness in the masses that what is the efficiency. Even we don't realize the thermal efficiency of the plants, power plants. Our government side plants have very reduced, moderate thermal efficiency, but the IPPs have got better efficiency. The capacity payment which you are paying, I am paying, and everybody is paying because of the IPPs is burdening for unused power. Please listen carefully. This is a paper in its place, but with my experience on the background, I can tell you so many things around. That you are paying out of your bill the accumulated capacity charges for the IPPs. That is the IPPs. So these are the private producers, and they have then there is theft of energy. Our infrastructure is so poor. We are still in 1960s. We have not updated. We even do not know what is energy efficiency and conservation in the domestic field. Now, out of it, see, on the Hadal side, we have got around 10,000 units. Acha, this is what you can say. This is the mistake of the planners of the country. Our side and proper side, they did not took care of to develop the indigenous resources. First, the hydel site, where we have got around 45,000 megawatt potential, and then another coal. Remember, all the way we were looking for how to exploit the coal. How to exploit the coal? Where's the tunnel? What to do? Even China offered us a very low tariff, 5.7 cents in 2005, but we were sleeping all the way. So I'm giving you this background. देखिए, जब हमारा supply side हम strengthen नहीं कर सके, formidable नहीं कर सके, और then we have to go for the expensive RLNG and rental plants and oil. We did not exploit our own indigenous hydel, and so that is the basic. That is where the energy crisis has emancipated, and simultaneously we freeze the tariff. Our tariff is such that we did not took care what are the international prices of oil. We kept it freezed in 2006 and 7, although the crude oil prices were climbing, but we just stopped the tariff. Recently, the power tariff has been again revised. Each disco will have its own tariff according to its own losses, according to its own supply, and according to their own cost benefit ratio. Okay, let's move. I told you today we are 40,923 megawatts, out of which 38,000 is in NTTC, old PEPCO, ex-DISCO or Wobbler system. And we started from a meager 70 megawatt. We started from a meager 70 megawatt in 1947. 60 megawatt in today's NTTC and PEPCO system, and 10 megawatt in this metropolitan city of Karachi. At that time, it was 10 megawatt, and today it is around 3,000. So you can see there is progress. I want to emphasize on the point that we are all the time cursing and crying for the crisis, energy crisis and power crisis. You are all, I'm sure, engineers, and you should be proud of it that we have developed to a great extent. Just from 70 megawatt, we have reached to 41,000 megawatt. This is the sort of appreciation for the nation. Next. Now, these are some reasons of the current crisis. Reduction of demand alone is just not the solution. Right? You can say you're already doing the load shedding. Then why are you asking for demand side management? You're already doing the load shedding, but that is creating great impact on the economy. Load shedding at the cost of industrial growth. Load shedding at the cost of economic growth. Load shedding at the cost of agriculture growth and overall growth. So these are certain reasons. That is, we are short of fuel. And why we are short of fuel? We are short of cash flow. Why we are short of cash flow? Our recovery is only 30%. Now, next, we have got hydro reduction, seasonal reduction. Okay. In winter, the hydel power generation is used, hydel resources are used, hydel water table is used for canals.
Sir, with due respect, I would like to suggest please try to conclude it because we are running short of time.
Sir, I'll give you a few minutes. I'm so passionate about this subject that I don't.
Thank you, sir.
I'm so passionate. I'm coming all the way from Hyderabad and trying to
Thank you,
address
sir.
this honorable gathering audience. Everybody's talking about the crisis, but we have to go to the root of the crisis. And then the solution, the academic solution is already there. There are equations, there are formulas, there are methods, there are calculations, there are software, homework, leap, we have applied all those things. But root.
Yes, sir. Please continue.
Thank you very much for giving me time. Then, if we go on with this population, we need to have 1,000 megawatts to be added to the current power generation capacity. The answer is, जब आपका इंडस्ट्रियल ग्रोथ नहीं है, सारा का सारा डोमेस्टिक ग्रोथ है, आपके 97% कंज्यूमर्स डोमेस्टिक है, तो आप किसे डेवलपमेंट करेंगे? You will go all the time for the imports, and then if you are going for the imports, where is your foreign exchange? What will happen to the country? What will happen? So this is the position. You need 1,000 megawatt to be added every year. This is not my report. This is the report from the ADB, Asian Development. And then, still, with all this growth around, 25% of the population and those who are living in the rural areas and those who are not connected with the grid, and Sindh and Balochistan and in northern areas, they are without electricity. Electricity is a necessity of life. It's no more a luxury. It is unfortunate that we are using it as a luxury and wasting the energy. That on that topic I'll come later. Move because I'm giving the signal of time. Achha. Now we have got 644 kilowatt, 644, which is 18 times less than the world average. On the one hand, we have got shortage of power. On the other hand, we don't have the efficiency. On the other side, we are accumulating the revenues. And on the other hand, such is our economic situation that our average per capita consumption is one of the lowest in the world. It is one of the lowest. And this is where we are. And for 1 unit of energy, I mean, the amount we use for develop $1 GDP, we are using 5 times more energy than Britain and 15 times more than the USA and 10 times more than the rest of the world. So this is the position. What we need to do is, अब क्या करें? We have applied everything. We don't have the resources. We don't have the funds. So we will ultimately have to go for demand side management. We'll have to go. I asked this question to the regulator, chief of the regulator, one day in Lahore. He said, what is your role on demand side management? They said, if we have got IPPs, but per force we have to take power from them. Otherwise, we'll have to pay for unused power. Okay? This way, we will increase the tariff. That way, we will increase the circuit depth, and then demand side management. That is only a paperwork. That is only in workshops or seminars. That is only limited to NECA. What is NECA? NECA is the National Energy Efficiency Conservation Authority. So, unless and until you do not come down to earth, और हम बच्चों को, why India is successful? They raised the institutions. उन्होंने बनाया, students are the ambassadors of energy conservation. उनके पोर्टल पे है गवर्नमेंट ऑफ इंडिया के, उन्होंने उससे बेतहाशा फायदा उठाया, एनर्जी बचाई, they are very successful. So we have to go. Okay, the energy audit should be taught in the universities. It should be implemented. It should not be left to the consultants and theoretical bodies. So this is one way. Move. I'm sorry, I'm taking time. Really sorry for that, sir. Move. Acha. So there. Okay, fine. Move, sir. Ladies and gentlemen, now there is a great environmental impact of demand side. All over the world, they are worried. What is the temperature? What is the global warming? How we can contain it? How we can stop it? 65% of the emissions are coming out of the fossil fuel generation, power generation. And we had gone into the Paris Accord in 2015, and Pakistan is a signatory of that agreement. And we are bound to reduce. We are bound to contribute. That is called our contribution. So, although we have got very little CO2 equivalent emissions, but we have by 30 it will be 890. Is somewhere. Anything which can play a role is the energy efficiency and conservation for cutting out the emissions. Move. Now, these are the areas how the DSM works. You have to go for the price, you have to give the incentives, you have to go for the penalties, critical peak price for the industries, but for the agriculturists and the energy efficiency and conservation, particularly in the residential sector, particularly in the domestic sector. We have to go for the retrofit. We have to go to the government sector. We have to stop the wastages. Move. Up, the major part can be played by use of smart meters, the AMI meters, or the prepaid meters. They are going to bring you the real results. Then that you see the tariff efficient incentives are there. The efficient appliances are there. Good afternoon. Then you see, now the inferior quality of accessories, wires and cables is playing havoc with our distribution system, particularly. Nobody is worried. What is the status of wiring in a house or in a new construction or the chokes? And what is the power factor? What is the size of the cable? How much are the losses? They are using it like anything. Then the air conditioners. I'm not talking of the control. I'm talking of the technology. At the moment, I'm talking of the technology and now the principles. I'm not asking that the conservation. You talk of the conservation. For example, Sahib is the chairman of IEEC. You say you're already doing it. You're doing the load shedding. Why the hell you not asking for demand side management? Huh? You understand? So these are the bird is going with technology. The bird is going moving with the technology. They're not living without technology. They're not even sleeping without technology. They are moving. Automation, robotics, artificial intelligence for planning and forecasting and for real results. भाई मैं क्या करूँगा? अगर आपने किताब बना के फेंक दी है कि ये एनर्जी कंजर्वेशन एक्ट है, ये बिल्डिंग कोड है, ये बिल्डिंग कोड के बाहर है. भाई here's the implementation. What is the installation? Exterior walls की क्या capacity है? Then replace inefficient submersible motor pumps. It's a very big area. It's a very big area. Most of the pumps are diesel pumps. More the diesel pumps. We can go for solarization. We can improve the motors. We can improve. And secondly, if we just go the power factor, which is around 40%, your own electrical engineers, you can imagine what havoc will play if the power factor is not close to unity. How much is the loss? I'm saying so. And with a very heavy heart. With a very heavy. Next. Achha. We talk that there is no employment of engineers in the country. But we have never, ever thought.
Sir, please. So
Yeah,
we have
sir,
next.
One moment, sir. I'm sorry to take your time. They should stop. Okay. I will obey you. I'll obey you. I'll obey you. The DS themselves, the role of the regulator, I'm saying so that जो NEPRA है, it has to play a role. मैंने क्या पढ़ा? इंडिया का जो स्टडी थी, उनकी यार जो DSM है, वो उनका रेगुलेटर, वो डिवाइस करता है, वो स्टेट यूटिलिटीज को देता है, फिर उसकी इम्प्लीमेंटेशन होती है, फिर उसकी मॉनिटरिंग होती है. तो टूल क्या है? या तो बिजली के बिल कम हो गए, या लोड शेडिंग नहीं होगी, या ग्रिड पर आपकी पावर कंजम्पशन कम होगा. तो वो कैसे होगा जब तक आपके स्मार्ट मीटरिंग नहीं होगी या आपको पता नहीं होगा. So how can you do it without involving NEPRA? So this is one of the way. And then prepaid meters. मेरे पर्स में 100 रुपए है, तो मैंने 100 के अंदर रहना है. If I want to prepaid meters, I have to live within my means. I have to. There is no choice. But today, I'm cursing the utilities and everybody, okay, my bill is too high and this and that. So this is one way. What Italy did, Italy, they were the first country to go for 20 million smart meters in 2000. They were the pioneers. They were the pioneers. These are the certain getting great people around. Huh? So these are out of my studies. देखिए हमें पता ही नहीं है हमारे फैंस कितने खर्च कर रहे हैं, लाइटिंग लोड कितना है, 34% लाइट लोड. मेरी एम्फेसिस बार बार यही है कि जो रेजिडेंशियल आपका सेक्टर है, वो जिसे कहते हैं ना, फरीदा आप भी यही है, वो उसको सारा हमारे बिजली के निजाम को चूस रहा है. इट इज सकिंग अप पावर सिस्टम. ना इंडस्ट्री को मिल रही है बिजली, ना हॉस्पिटल्स को मिल रही है, ना एग्रीकल्चर को मिल रही है. आवर modern urbanized society is misusing or using whatever you can say. These are the elements. Look, हम स्टील मिल वाले 700-800 kilowatt पर टन पे बनाते हैं, जबकि मॉडर्न में 200. So Alba finish on that. So these are the things. If we do this, we have to implement this. There's no way.
Thank you.
There's no way. I'm sorry. मैंने गुस्ताखी की है आपसे. I'm sorry.
Thank you very much. It was a presentation and a very good informative knowledgeable session. This is open for questions. Please.
Recording.
मैं होमवर्क अप्लाई कर सकता हूँ, लीव पे अप्लाई कर सकता हूँ, मार्क पे अप्लाई कर सकता हूँ, मैं रिजल्ट दे सकता हूँ, ये रिजल्ट आ गया जी, इसके बाद ये आ गया 52050 ये मेरी लीव की कैलकुलेशन है, ये
Electrical Engineering Conference 2023, jointly organized by the Institution of Engineers Pakistan, Karachi Center and NED University in collaboration with Federation of Engineering Institutions of Islamic Countries, Federation of Engineering Institutions of South and Central Asia, United Nations
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم اسم ربك الأعلى الذي خلق فسوى والذي قدر فهدى والذي أخرج المرعى فجعله غثاء أحوى سنقرئك فلا تنسى إلا ما شاء الله إنه يعلم الجهر وما يخفى ونيسرك لليسرى فذكر إن نفعت الذكرى سيذكر من يغشى ويتجنبها الأشقى الذي يصلى النار الكبرى ثم لا يموت فيها ولا يحيا قد أفلح من تزكى وذكر اسم ربه فصلى بل تؤثرون الحياة الدنيا والآخرة خير وأبقى إن هذا لفي الصحف الأولى صحف إبراهيم وموسى صدق الله العظيم.
Jazakallah. Ladies and gentlemen, you are now requested to rise for national anthem. The guests may now take their seats. Ladies and gentlemen, Today we have with us a very proficient researcher, Professor Dr. Shahril Azmin Sundi from School of Electrical and Electronics Engineering, University Science, Malaysia. His research interest includes artificial intelligence, computer vision and pattern recognition, face and facial features detection, tracking, recognition, object tracking for motion, and state recognition in video sequence. He is a chartered engineer and also a senior member of the Institute of Electrical and Electronics Engineer. Now it is my pleasant duty to invite Professor Dr. Shahril Azmin Sundi to present his keynote address.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. A very good evening to all. My name is Shahril Azmin Swandi. I'm from University Science, Malaysia. And today, in my talk, I will talk about Q-learning embedded sine cosine algorithm. We give an abbreviation to it, QLESCA, and this is going to be used for engineering applications. This is my presentation outline. I'll start talking about the background of this proposed algorithm, followed by motivation. And then we go a little bit on the theoretical part of QLESCA. And then I'll move into QLESCA and its engineering applications. And then after that, I will conclude and together giving the future works. At the end of my presentation, I will share a bit on the acknowledgement and my publications. Let's talk about the background about this research. Basically, QLESCA is an optimization algorithm being proposed recently based on sine cosine algorithm. When we talk about optimization, then this is one of So in our work, so how do we improve the COVID-19 detection using CNN? And finally, so this is SEA. Why? Because of how do we solve all this in simple way, which means that we need to try to optimize the informations that we have in hand. Do we have limitations of data? Even though we have limitations, but we have a lot amount of features being extracted using CNN. Okay, and then at the same time, we have to make things easier because we want it to perform, as fast as possible. So this is the three motivations finally come to SCA. So you wonder how to improve SCA by avoiding linear behavior of switching between exploration and exploitation phase. So therefore, we propose this QLESCA, where you may see that later in the concept of this algorithm, it solves the problem of this linearity in SCA. So in my talk today, I will just briefly introduce this, and I will share with you all what is the benefits of using the QLESCA. So as I mentioned previously, so this is how it works. And then the second step, where we try to minimize we try to determine the best model for VGG19, and then based on the model that we have, to simplify the model, then we use that model in two applications, which are filters and then feature selection. Let's see how it works. So conceptually, when we use this QL means Q learning, we just embed this Q learning into SCA. So SCA works as it is, but we try to manage R1 and R3 depending on the states, which is the environment. So how to do this is based on this. So we have SCA search agent. So we have, this is basically the functions that we try to solve. Based on this, we use two indicators, density as well as distance, to determine the states. Then because of we need states, and based on these states and results coming from these functions, we have to compute, because of this is considered the function is considered as the environment, and we have to compute, give the reward or penalty based on this environment, and then we have to know the state, so that these two information, state and reward, will be used by the agent to build the Q table. So based on the Q table, it will provide action accordingly. So this action will be used in the optimization, and then this will be repeated until we get the result. This is the initial state, where we will initialize all states into 0. So take note that we have 9 states, okay, 1 until 9, where we have this high and high, medium, and so on, until the state number 9, where it is density low and distance low. It means that density means all agents are very near to each other, and if it is high. But if its density is low, it means that the distance, the density means that the position between all these agents are far from each other. And for distance-wise, then it is distance means distance between all agents. Okay, so this is we have, if they are near to each other, the distance is very low, and if they are far from each other, then the distance will be high. Okay, so therefore what we want is density should be very high, as well as the distance should be very low, because they are near to each other. And for this structure, we have also for Q table, we have actions where we have R1 and R3. So we control these two parameters. So whether they are depending on the values being generated, whether they are H, whether high and high, because we divide them into three regions: low, medium, and high. So this is the initial state. And then this is to illustrate the density is high, they are near to each other. And then this is also distance equals to low, because of they are near to each other. So this is state number 3 here. Density is high, and then distance is low.
Okay, so this is the meaning. So this is conceptually that this is what we want, as long as it goes to the global optimum. So when we use this QLASCA, we notice that R1 behaves something like this. So it's no more linear like this, but now it corresponds. Okay, it responds to the environment accordingly. So these are some of the experiments that we have conducted. Okay, when we compared with other optimization algorithm, and we may see that the QLASCA is the best one. Okay, you may see this curve. Okay, and then when we applied this to COVID-19 detection, okay, using X-ray images based on this evaluation metrics, we also noticed that, so these are the data that we have used, and we noticed that the results given are very promising. So for this, when we try to use, this is shallow, this is medium, and this is a very deep model of VGG19. We notice that when we use a shallow model, it gives us the best results. So we stick to this shallow model in our future work. So in the other two applications that we have experimented, so the first one is to select the filters. So this is the structure that we have. So we try to use this COVID-19 application, okay? And then this is shallow CNN, where this is a structure for training. So once we have trained, then we use the model here in the testing data set, and we may see that the results given to us is very promising. So here we only use 51, and you may see that accuracy is 97% when we compare with some other algorithms. Besides this, we also tested for feature selection. Feature selections means there are features exist within this framework. We try to go and find important features after being extracted by CNN. So we apply at this point. So this is another model that we have built, and we notice that, so I will skip this, okay. And this is the result that we obtain. So number of features being used in this work is 38, and we make comparison with other approach, where this is a sine cosine algorithm together with SCNN, means within the same of this, okay, shallow CNN and SVM. We have this 26, but this is for number of features. But when we compare the performance, so our proposed method, QLASCA, CNN, and SCNN and SVM, we obtain the best result, okay, when we compare this. So in conclusion, I have shared with, in my talk, the new SCA variant optimization algorithm known as Q-learning embedded sine cosine algorithm. So this has been published in Expert System with Applications. We have tested this on CNN model, and it works better with QLASCA for COVID-19 patient detection through X-ray images. So we have examined using filter and features approach, and both showed the best result. But when we compare these two, if we compare these two, so here the accuracy 97.8086, while this is 97.222, means that comparing these two, it is better to use features selection for this application. So these are some of our publications, and I would like to acknowledge that this work has been performed and executed with this research grant coming from Malaysia Ministry of Higher Education. With that, thank you very much. I hope you enjoyed this talk. If you have more questions, please contact me at the email given in my first slide. Thank you, and see you all again. Bye-bye.
Thank you, sir. Now I would like to request Engineer Professor Dr. Saad Ahmed Qazi, Dean Electrical and Computer Engineering, NED University and Convener 8th IEEC 2023 to give highlights of conference.
Thank you, Najia. Bismillahir Rahmanir Rahim. It's a pleasure to be in the company of such esteemed guests. I will start with Engineer Amir Zamir Saab, Secretary General IEP, President IEP, Dr. Sarosh, Vice Chancellor NED University, respected guests from IEP, from industry, from the universities who have joined us in the conference, the paper authors, presenters, faculty members, and students. Assalamu alaikum. It's a pleasure talking to you and give you the conference highlights. As I mentioned, the electrical engineering is facing amazing challenges. And when I say amazing challenges, it's because the challenges can be transformed into opportunities. And this is the 8th International Conference of Electrical Engineering that happened. And I'm sure over the last 2 days, yesterday and today, gave us ample opportunities to identify the challenges and opportunities that are coming to us in this area. Today, if you look at the newspapers, you will find that the market and the consumers are not able to pay their bills, as was mentioned yesterday by Farhat Adil Saab also. Although that's very troubling for all of us, but as researchers and as professors and as industry representatives, it is our responsibility to see how we can provide solutions to these problems. And before the start of this closing session, I was part of the soft launch of one of the projects that took place at 2 p.m. in the mechanical hall. And I was noticing a beautiful blend of collaborators that was present there. Starting with the PNG, it came up through Hasham Saab, who was director of PNG till a few months ago. He identified a need at his company. He approached the NED University faculty that what sort of solutions can be driven. And in fact, he was inspired by one of the final year projects he witnessed at the FIP exhibition held at Computer Systems Engineering. Then came in the funding agency. In that case, it was the Technology Development Fund. So there was an industry, provided access, there was a need, there was a university who provided the research expertise, the faculty and the students. Then there was a funding agency which funded that project. Then there came in a commercial partner who provided the design cycle expertise to take on the proof of concept to the level where it can be deployed to industries, where it can meet the international standards and it is acceptable to the industries which can buy it and be a part of the national economy. Because most of the time when one of the stakeholders work on anything without collaboration, the idea at max reaches the tier 1 level only, and then it fizzles out, never reaches the market, never contributes into the national economy. Then there was a beautiful platform offered by Institute of Engineers Pakistan, which is the dissemination and the awareness and advocacy. So the product will launch through the collaboration of IEP. So these 5 collaborators, I think that in any project, when you include these as ingredients, will create the impact which is necessary from the ideation or the conceptualization phase to reach the market level and be a part of national economy. As I said, this will result in the production of the solutions to the problems we are facing today. So I really hope that this conference has generated that discussion. If you look at the numbers, alhamdulillah, they are increasing over the years. This year we had 75 submissions, out of which 30 were accepted. There were 16 different partner institutes and universities whose presentations were made. There were 3 international keynotes and invited talks, 9 invited industrial talks, which were part of today's and yesterday's agenda. So I think that is very rich, and I really congratulate the organizing committee, Dr. Ablo, Dr. Mohsen, and his team. I would like to thank Sohail Bashir Saab, his team, for helping us as always in organizing such conferences. And once again, I congratulate and thankful to the authors who have presented their papers. Thank you very much.
Thank you, sir, for your valuable words. Ladies and gentlemen, now I request Engineer Sohail Bashir, Chairman, Institution of Engineers, Pakistan, Karachi Center, to please come to deliver his address.
Bismillah ar-Rahman ar-Rahim. As Chairman of the Institution of Engineers, Pakistan, Karachi Center, I welcome you all to the closing ceremony of the 8th International Electrical Engineering Conference. फरद आदिल साहब ने कल मोड चेंज किया था, तो मैं भी मोड चेंज कर लूं ताकि बाकी मेरे बाद में आने वाले लोगों को आसानी हो। मैं ये समझता हूं कि ये इंस्टीट्यूशन ऑफ इंजीनियर्स, एनईडी यूनिवर्सिटी और जितनी हमारी पार्टनर यूनिवर्सिटीज़ हैं, जिसमें मेहरान यूनिवर्सिटी ऑफ इंजीनियरिंग टेक्नोलॉजी, कायदे अवाम यूनिवर्सिटी, बलूचिस्तान यूनिवर्सिटी ऑफ इंजीनियरिंग टेक्नोलॉजी खुजदार, बलूचिस्तान यूनिवर्सिटी ऑफ इंजीनियरिंग ब्यूटम्स कोयटा, सारे लोग यहाँ बैठे हुए हैं माशाल्लाह। हमदर्द यूनिवर्सिटी, बैरिया यूनिवर्सिटी, सर सैयद यूनिवर्सिटी, PF Keat, and then probably yes, Institute of Industrial Electronics, PCSIR. Then also the two international collaborators, Federation of Engineering Institution of Islamic Countries, Federation of Engineering Institution of South and Central Asia, ASHRAE, Pakistan. Then we have National Center for Robotics, National Center for Big Data, National Center for Automation and Artificial Intelligence. So, इतने सारे लोग मिलते हैं तो फिर ये कॉन्फ्रेंस होती है। और जैसे मेरा ख्याल है इस कॉन्फ्रेंस का एक बहुत बड़ा आउटकम जो कि साद काजी साहब ने मेंशन किया कि इस कॉन्फ्रेंस की बहुत बड़ी कामयाबी जो इस दफ़ा हुई है वो ये है कि हम इंडस्ट्री के साथ जो कोलैबोरेशन हुई है उसको शोकेसिंग कर सकें। प्रॉक्टर एंड गैम्बल दुनिया की एक बहुत बड़ी कंपनी है, पीएनजी की बात ही। प्रॉक्टर एंड गैम्बल ने एक प्रॉब्लम आइडेंटिफाई की, यूनिवर्सिटी उस प्रॉब्लम को लेके चली, उसमें इंटरनेशनल फंडिंग आई, फंडिंग के साथ फिर कमर्शियल पार्टनर आया और आखिर में अल्लाह का शुक्र है कि आईपी को ये एक पूरे की पूरी टीम को लीड करने का और प्रेजेंट करने का मौका मिला। मैं समझता हूं कि इस सब में आईपी के जबरदस्त जो है एक कार्रवाई है। इसी तरीके से आप इसके अंदर इसमें जो पेपर्स प्रेजेंट किए उसमें से बहुत सारी चीजें जो है वो ऐसी निकली हैं जिससे आगे काम होगा। आप में से बहुत सारे लोगों का जो खासतौर पे हमारे जो दोस्त आए हैं उसमें वापडा से बड़ा गहरा ताल्लुक रहा है और आजकल लोगों की चीखें निकली हुई हैं बिजली से। हर आदमी बिजली को जलाता फिर रहा है, बिजली के बिल को जलाता फिर रहा है। और ये जो है ना इस वक्त कल जो है ना वो के इलेक्ट्रिक के कुछ लोग टिम्बर मार्केट में जो है ना बिजली काटने गए थे, उन्होंने जो बेचारा सामने वाला जो एमटीएल के ऊपर एक बंदा है उसको मारा और ये किया वो किया। लेकिन मेरा ड्राइवर कह रहा है कि साहब मैंने अपने घर वालों को इतना रोका है, मैंने डीप फ्रीजर अपना फ्रिज बंद करवा दिया, ये करा दिया, वॉशिंग मशीन बंद करा दी, यूनिट कम है बिल ज्यादा है। कह रहे 12,000 रुपए का मेरे घर का बिल आया। तो ये सारी सूरत, ये एक चैलेंज है। मैं कल भी हमने डिस्कस किया था कि इस चैलेंज को ज़ाहिर है हम पूरे एज ए मनहसल कौम हम इस चैलेंज से गुजर रहे हैं और इंस्टीट्यूशन ऑफ इंजीनियर्स की ये जिम्मेदारी है कि इस चैलेंज पे लोगों को सोल्यूशन बताएं कि क्या सोल्यूशन है। ऑल्टरनेटिव एनर्जी के अलावा हमारे पास जो हम थर्मल पावर है, जहाँ के थर्मल पावर में हमारा सबसे बड़ा बिल जो है वो फर्नेस ऑयल का है, हम उसको इंडिजीनियस कोल के साथ करें। और कल ही आसिम मुर्तजा साहब ने एक बहुत बात की थी कि इस वक्त हमारी जो इंजीनियरिंग है इसका एक मेजर कंपोनेंट ये है कि हम कैसे इंडिजिनाइजेशन करें, कैसे इंडिजीनियस सॉल्यूशंस हम लेकर आए, ताकि इस वक्त जो हमारा दुनिया में एक इंपोर्ट बिल की वजह से हम एलसीज नहीं खोल पा रहे, हमारे पास फॉरेन एक्सचेंज का प्रॉब्लम है। हमें इस वक्त जो बहुत इंपॉर्टेंट काम है कि हम रिवर्स इंजीनियरिंग के ऊपर जाएं, जो हम कंपोनेंट्स इंपोर्ट करते हैं हम इंपोर्ट की जगह जो है हम लोकली उसको मैन्युफैक्चर करने की कोशिश करें। अल्हम्दुलिल्लाह यहाँ पे टैलेंट है। हम जो है हमारे इंजीनियरों ने इस मुल्क के अंदर जो है सारी दुनिया के रोकने के बावजूद जो है न्यूक्लियर बॉम्ब बनाया, न्यूक्लियर टेक्नोलॉजी लेकर आए। तो हम में से हमारे इंजीनियर जबरदस्त सलाहियतों वाले हैं। इंशाल्लाह ताला हम सब मिल बैठ के कोशिश करेंगे, इन सारी चीजों की सॉल्यूशन नजर आएंगे। میں زیادہ لمبی بات اس لیے نہیں کرنا چاہتا کہ میرے بعد بہت سارے لوگ ہیں. میں آپ سب کا خاص طور پہ جو ہمارے مہمان باہر اسلام آباد سے لاہور سے تشریف لائے امیر ضمیر صاحب کا شکریہ کرتا ہوں. ہمارے وائس چانسلر NED یونیورسٹی ڈاکٹر سروش لودھی کی ہمیشہ ہمارے ساتھ سرپرست رہی ہے. میں چیئرمین لاہور سینٹر کا, چیئرمین پشاور سینٹر کا, سیکریٹری لاہور سینٹر, اور باقی ہمارے جتنے احباب لاہور سے اور اسلام آباد سے اور خاص طور پہ جو بیوٹم سے اور بیوٹ سے آئے, میں آپ سب کا بہت شکر گزار ہوں کہ آپ لوگوں کے آنے کی وجہ سے ہماری اس کانفرنس کو 4 چاند لگ جاتے ہیں. اور اس کانفرنس کی جو ایک سب سے بڑی خصوصیت ہے کہ ہمارے خوش نصیبی ہے کہ ہماری وائس پریزیڈنٹ الیکٹریکل اسلام آباد سے بنفس نفیس خود تشریف لائی ہیں یہاں پہ. میں بہت ان کا شکر گزار ہوں. ان کو اس بات کا بھی شرف حاصل ہے کہ یہ اس انسٹیٹیوشن کی پہلی لیڈی الیکٹریکل انجینئر تھی. تو یہ میں سمجھتا ہوں کہ ماشاءاللہ ایک اچھی کانفرنس ہوئی. تھوڑی دیر بعد ہم اس کانفرنس میں ہمارا ایک وہ طریقہ کار ہے, اس وقت ایویلویشنز ہو رہی ہیں کہ بیسٹ پیپر جو ہوتا ہے اس کو چیئرمینس ایوارڈ دیا جاتا ہے, میڈل دیا جاتا ہے, اور اسی طریقے سے بیسٹ پوسٹر کو بھی ڈکلیئر کیا جاتا ہے. وہ تھوڑی دیر میں آتا ہے. میں آپ کو ہینڈ اوور کرتا ہوں کہ آگے چلیں. تھینک یو.
Thank you, sir, for your kind words. Now, I would like to request Engineer Farida Javed, Vice President, Electrical Institution of Engineers, Pakistan, to please come to address the audience.
السلام علیکم وائس چانسلر صاحب اور سارے آڈینس, ضمیر مرزا صاحب, وائس پریزیڈنٹ صاحب سوری, میں پہلے پریزیڈنٹ صاحب کا نام لینا چاہیے تھا, اور میری پیاری اسٹوڈنٹ. مجھے بڑی خوشی ہوئی ہے. آئی ایم ویری ہیپی ٹو بی ہیئر. جیسے مجھے پتا چلا یہاں ہو رہا ہے فنکشن تو میں نے کہا میں ضرور جاؤں گی. ہمارا تو وی ہیو IEP میٹنگ ٹمارو, لیکن میں آئی یہاں پر. مجھے بڑی خوشی ہوتی ہے. ہم نے تو پرانے کالج سے کیا ہے, کو پتہ ہی ہوگا زمانے میں ہم سوچ رہے تھے کہ بنے گا, لیکن ہمارے زمانے تک نہیں بن پایا. میں نے جو کیا ہے ہم لوگ, آئی ایم ناٹ اونلی ون, وی ور 3 لیڈی انجینئرس, تو یو کین سے آئی ایم ون آف دیم. لیکن یہ ایک بہت پراؤڈ ہے ہمارے سب کے لیے, کیونکہ ہم نے بڑے اس زمانے میں محنت کی. 64 میں جوائن کیا اور 70 میں ہم 66 میں جوائن کیا, 70 میں نکلے ہم. اس زمانے میں NED میں فرسٹ ٹائم لیڈیز نے کیا, بعد میں پنجاب میں یا UT لاہور میں بعد میں لیڈیز آئی ہیں. NED نے لیڈ کی ہے پہلے. وہ ایک تھی حمیدہ اور رفیدہ. حمیدہ وہاں پر ہیں دبئی میں, اور رفیدہ ادھر ہیں ہیوسٹن میں. تو حمیدہ تو کام کر رہی ہیں, ان کا اپنا سیٹ اپ ہے, اور رفیدہ ابھی ریٹائر ہو گئی ہیں, نہیں کرتی. میں بھی ریٹائر ہو گئی ہوں. میں نے اباؤٹ 40 ایئرس سروس کی ہے, اور ڈفرینٹ آرگنائزیشن میں. اکثر مجھے یاد کرنا پڑتا ہے کہ میری کتنی آرگنائزیشن ہو گئی ہیں. تو آئی واز ان اسٹیل مل ایز اے ایکسین, پھر میں نے ٹریننگ کی باہر. تو مجھے اس بات کی بڑی خوشی ہے کہ میں نے پروفیشنل کام کیا ہے میں نے کافی. تو دین آئی جوائن پالی ٹیکنیک انسٹیٹیوٹ ایز اے پروجیکٹ ڈائریکٹر. وہ پروجیکٹ تھا 8048 پروجیکٹ, وہ میں نے بنایا. اور میں آئی ریمین پرنسپل فار دا 22 ایئرس, جو کہ ایک ریکارڈ ہے کہ 22 سال کوئی پرنسپل نہیں رہی اس کی. مطلب فرام 86 to 2009. اور ڈیورنگ دیٹ ٹائم I was posted to Manila, Colombo Plus Staff College. It was a very good honor for me, کیونکہ وہاں پر بہت مشکل سے there were 28 candidates. یہ کولمبو پلس اسٹاف کالج ہے منیلا میں فار ٹیکنیشین ایجوکیشن, جو کہ کیٹر کرتا ہے پولی ٹیکنیک کو, ریجن کے پولی ٹیکنیک کو. دیر آر 19 کنٹریز جو فنڈ کرتے ہیں اس کو. پاکستان بنا تھا فاؤنڈر ممبر اس کا. تو دیر واز 28 candidates اور 12 فرام انڈیا. تو آئی واز سلیکٹڈ, اٹ واز آنر فار می. تو میں نے وہاں 3 سال کام کیا ڈفرینٹس میں. تو زیادہ تر ٹیکنیکل ایجوکیشن میں میرا فیلڈ رہا, بہت زیادہ مجھ سے کیا. ڈیورنگ دیٹ سروس میں چھٹی لے کے گئی تھی اس میں, پھر واپس آ کے یہ اپنا کمپلیٹ کیا, پروجیکٹ کمپلیٹ ہوا. اور یہ پروجیکٹ جب میں نے جوائن کیا پولی ٹیکنیک, دیر ور اونلی 30 اسٹوڈنٹس, کرائے کی بلڈنگ میں تھا. تو یہ پھر ایک پروجیکٹ تھا. اب ناؤ جب وین آئی لیفٹ دیر ور 500 اسٹوڈنٹ وتھ 200 لیڈیز کا ہاسٹل تھا, اور لاٹ آف ٹیکنالوجی, یعنی جو اور جگہ نہیں ہوتی ہیں. تو وہ کیا. اس کے بعد میں پھر کونسل جوائن کیا ایز اے ایڈوائزر لاہور میں. امین مرزا صاحب گواہ ہیں کہ آتے تھے وہاں پہ. انہوں نے مجھے بڑا سب سے پہلے مجھے انہوں نے ایوارڈ بھی دیا کہ میں لاہور آ گئی ہوں ایز اے ایڈوائزر, اور 3 سال میں نے وہاں کام کیا. اس کو اپلفٹ کیا. بہت چھوٹا سا آفس تھا اور 3rd فلور پہ تھا, تو لوگ آتے آتے تھک جاتے تھے, تو پھر ہم نے نیچے بنایا اس کو. بڑا اچھا رہا, بڑا اچھا میرا جاب رہا وہ. پھر اس کے بعد 65 سے میں ریٹائر ہو گئی. لیکن میں اب بس یہ کام کرتی ہوں جو آپ نے دیکھا کہ الیکشن لڑنا پی سی کے اور آئی پی کے, تو اس طرح سے اس میں ہمارا ٹائم گزارتی ہوں. بڑا انجوائے کرتی ہوں میں اس طرح سے کہ اپنے. اور دوسرا یہ کہ اگر جاب مل جاتے ہیں, لیکن میں خود سے نہیں کرنا چاہتی. جاب کروں تو پھر تھوڑا یہ اپنے مذہب کی طرف یہ ہمارے وہ کمی آ جاتی ہے. تو میں نے کہا اب اس زمانے میں ہمیں تھوڑا وہ بھی کرنا چاہیے, روز یہ رکھنا یہ کرنا. تو اس لیے میں بہت کم جاب نہیں کرتی, بس یہ میں آئی پی میں ادھر ادھر آ جاتی ہوں. تو بہت خوشی ہوئی آپ کی سب کے سن کے. بس میں نے کل کا بڑا مس کیا, لیکن اچھا بہت شکریہ آپ کا. اللہ حافظ. ابھی میں بالکل بتاؤں گی, بلکہ ایک بڑی چھوٹی سی اسٹوری سننے بڑی انٹرسٹنگ ہے کہ اس زمانے میں 5 سیٹس ہوتی تھی لیڈیز کی, 5. تو ہم نے کیا دیر ور 6 لیڈیز, 6 لڑکیوں نے اپلائی کر دیا. اب پروفیسر انور چودھری ہمارے اسپورٹس کے تھے اور بہت محبت کرتے تھے اسپورٹس مین سے. اس نے مجھے کہا کہ آپ نے کچھ اسپورٹس میں کیا؟ میں نے کہا میں چیمپئن اسکول کی, انٹر اسکول کی, انٹر کالجیٹ کی, انٹر اسکول کی. تو کہنا تو کہتے تھے کہ تو اس میں اسپورٹس پہ آ جائے تاکہ 6 لڑکیاں آ جائیں آپ کی 6. تو اس طرح سے میں نے اسپورٹس میں داخلہ لیا. اور ٹیبل ٹینس کھیلا ہمیشہ. میں یونیورسٹی چیمپئن اور وہ ویسے بھی کافی رہی ہوں. لیکن رخسانہ زبیری آپ سب جانتے ہوں گے, وہ میری وجہ سے ان کا نمبر 6 تھا, تو وہ انجینئر بن گئی. اب وہ بیچاری اتنا ہر جب بھی آتی ہے نہیں میرے کالج آتی ہیں, نہیں وہ کبھی شرماتی نہیں ہے. میرے کالج میں بلاتی ہوں ایز اے چیف گیسٹ نا, تو انہوں نے میری ٹیچرس کو بتایا, مجھے بھی یاد نہیں تھا, انہوں نے بتایا کہ میں ان کی وجہ سے انجینئر بنی ہوں. وہ اس لیے ہم نہیں, لیکن وہ چھپاتی ہے نہیں. اگر وہ چھپاتی ہے میں کبھی نہیں بتاتی. وہ خود بڑے سے فخریہ بتاتی ہیں کہ یہ اسپورٹس پہ آ گئی تھی, اس لیے میں نے اس میں انجینئر بن گئی. ہاں لیکن انجینئرنگ کا کام میں نے کم کیا, پالیٹکس زیادہ کی ہے. اچھا, تھینک یو سو مچ. اللہ حافظ.
Thank you, Madam, for your enlightening address and your esteemed presence here. Now, I would like to request Engineer Amir Zamir Ahmed Khan, Secretary General, Institution of Engineers, Pakistan, to please come to deliver his address.
نحمد و نصلی علی رسول الکریم. اما بعد فاعوذ باللہ من الشیطان الرجیم. بسم اللہ الرحمن الرحیم. محترم انجینئر سروش لودھی صاحب, محترم انجینئر فرت عادل صاحب, پریزیڈنٹ انسٹیٹیوشن آف انجینئر پاکستان, محترم چیئرمین انسٹیٹیوشن آف انجینئر کراچی سینٹر, محترم وائس پریزیڈنٹ انجینئر ایاز مرزا صاحب, محترم سیکرٹری لاہور کراچی سینٹر, اور باقی دیگر انجینئر خواتین و حضرات. کل جب ہمارا پروگرام بنا کراچی آنے کا, تو ہمارے ڈائریکٹر جنرل نے جو سیٹس بک کرانا چاہیں, تو پتہ یہ چلا کہ کراچی, لاہور اور لاہور اسلام آباد جو ہمارا یہ سیکٹر ہے, اس پہ آج کل بہت کم جو ایئر لائنز ہیں وہ آپریٹ کر رہی ہیں. جب وجہ پتہ چلی کہ ابھی ریسنٹلی پاکستان کو اجازت ملی ہے کہ جو انٹرنیشنل ہماری فلائٹس ہیں جو جا رہی ہیں, جو کافی 3-4 سال سے جن پہ بین لگا ہوا تھا, انٹرنیشنل روٹس پہ پاکستان کو اجازت مل گئی ہے. تو یہ جان کر خوشی ہوئی, آپ کے تالیوں کے ہاتھ بج رہے ہیں, کہ ہر چیز نیگیٹو نہیں ہے. صرف بجلی کے بل نہیں جل رہے پاکستان میں, اچھی خبریں بھی ہیں کہ پاکستان کے اب ایئر لائنز جو ہیں انٹرنیشنل روٹس پہ ان کو اجازت مل گئی ہے, اور جو ڈومیسٹک روٹس ہیں اس پہ بہت کم فلائٹس اویلیبل ہیں. تو انہوں نے یہ کہا کہ PIA کی صرف فلائٹ اویلیبل ہے صبح آنے کے لیے، اور کوئی جو دوسری پرائیویٹ فلائٹس ہیں ان پہ اجازت نہیں ہے۔ میری جو مسز ہیں ان کے بھائی کی پوسٹنگ ہوئی پچھلے ہفتے یہاں پہ IG سندھ لگے، تو انہوں نے رات ٹیلی فون کر دیا اپنے بھائی کو کہ میرے میاں کراچی آ رہے ہیں، تو آپ ذرا ان کو پروٹوکول دے دیں تو میری بھی ذرا عزت بن جائے گی۔ تو پہلے تو یہ ہے کہ جب ہم PIA میں جب انٹر ہوئے، جب جہاز میں انٹر ہوئے، تو مجھے مرحوم عمر شریف یاد آ گئے، اور میں نے عمر شریف کو مغفرت کے لیے دعا کی، اور مجھے ان کا وہ انڈیا میں جو شو یاد آ گیا، جب انہوں نے کہا کہ میں PIA کے جہاز میں جب انٹر ہوا تو مجھے جو ایئر ہوسٹس ملیں تو مجھے اپنی وائف یاد آ گئی کہ میں گھر پہ بھی جو چھوڑ کے آیا تھا مجھے ایئر لائن پہ بھی وہی خاتون مل گئی۔ بہرحال جو دوسری ہمیں ایئر ہوسٹس ملیں تو وہ بھی اس سے کم نہیں تھیں، اور وہ جب ہمیں سرو کرنے آئیں تو ہمارے جو دوست تھے وہ اپنی اپنی پکچرز بنا رہے تھے، تو وہ آ کے کہتی ہیں کہ میں آپ کی پکچر بناتی ہوں، اور وہ یادگار پکچر بنائیں گے، اور وہ بڑی زبردست پکچر بنے گی۔ تو جو ان کی حرکتیں تھیں، میں نے ان کو دیکھ کے کہا کہ بی بی آپ جوانی میں کتنی اچھی ہوں گی اور کتنی خوبصورت ہوں گی۔ تو مجھے کہنے لگیں کہ میں اب بھی جوان ہوں، آپ مجھے دیکھیں تو صحیح ذرا۔ تو پھر میں نے ان کو کہا کہ آپ واقعی جوان ہیں، اور مجھ سے تو کم از کم زیادہ جوان ہیں، لیکن میں پوچھ سکتا ہوں کہ آپ کی چھوٹی بیٹی آج کل کون سی ایئر لائن میں کام کر رہی ہے؟ آپ تالیاں بجائیں گے تو یہ شام کا ٹائم ہے تو انجوائے کریں گے۔ ہم یہ الیکٹریکل انجینئرنگ سن کے اور پڑھ کے میرا خیال تھک چکے ہوں گے، میں بول کا تو لفظ نہیں کہہ رہا، ٹھیک ہے، کوئی مسئلہ نہیں، یہ لیک بھی ہو جائے تو کوئی مسئلہ نہیں۔ اچھا، اس کے بعد جب ہم اترے، اپنے جہاز میں اترے، تو مجھے ٹیلی فون آیا کہ جی میں پولیس سے بول رہا ہوں اور میں SSP ہوں، تو میری ڈیوٹی لگی ہے IG صاحب نے کہ آپ کو پروٹوکول دینا ہے۔ تو میرا SHO جو ہے اس نے ایک پروٹوکول افسر کی ڈیوٹی لگائی ہے، وہ آپ کو پروٹوکول دے گا۔ تو میں نے ان کو کہا یار کہ میں تو کوئی اتنا امپورٹنٹ آدمی نہیں ہوں، لیکن جو میرے ساتھ آ رہے ہیں وہ بڑے امپورٹنٹ لوگ ہیں، انسٹیٹیوشن آف انجینئرز پاکستان کے وہ گورننگ باڈی کے ممبر ہیں، اور وہ واقعی پاکستان کی کریم ہیں۔ تو تھوڑی دیر بعد ایک اور افسر کا ٹیلی فون آ گیا، SHO کا ٹیلی فون آ گیا، اور اس کے بعد پھر ایک پروٹوکول افسر کا ٹیلی فون آ گیا۔ اس نے کہا جی کہاں ہیں؟ میں نے کہا لینڈ کر چکی ہے فلائٹ۔ تو اس نے کہا جب آپ جہاز سے اتریں گے تو جو واکنگ ایریا ہوتا ہے میں وہاں پہ انتظار کروں گا۔ میں نے کہا ٹھیک ہے۔ ہم جب وہاں سے اترے، واکنگ ایریا میں آئے، میں نے ٹیلی فون کیا تو میں نے کہا آپ کہاں ہیں؟ کہتے جی میں تو آپ کو لے کے سیڑھیاں بھی اتر چکا ہوں۔ تو میں نے کہا مجھے لے کے اتر چکے ہوں؟ کہتے جی آپ کے ساتھ آپ کی وائف بھی ہیں۔ تو میں نے کہا اچھا یہ کیا ہوا، میں تو ابھی واکنگ ایریا میں پہنچا ہوں۔ کہنے لگے سر میں نے آپ کو پوچھا ہے کہ آپ عامر ضمیر ہیں؟ تو میرا چونکہ امیر ضمیر ہے تو انگلش میں وہ غلطی سے شروع سے AMIR لکھا گیا، تو وہ عامر ضمیری کہتے ہیں، میں بھی ایکسیپٹ کر لیتا ہوں۔ کہتے ہیں جی میں نے 2-3 دفعہ آپ سے پوچھا ہے کہ آپ عامر ضمیر ہیں، عامر ضمیر ہے، تو آپ نے کہا جی میں عامر ضمیر۔ وہ میں نے کہا بھائی میں تو ابھی آ رہا ہوں راستے میں، تو آپ نے کس کو پکڑ لیا؟ یہ فلموں میں تو دیکھا تھا کہ ایک ہیرو کو وہ بندہ پکڑ کے لے گیا، دوسرا کہیں اور چلا گیا، تو یہ آج کراچی ایئرپورٹ پہ ہمارے ساتھ کیا ہو رہا ہے؟ بہرحال میں نے کہا میں آ رہا ہوں۔ کہتا جی آپ سیڑھیوں کے نیچے آ جائیں۔ جب میں نیچے آیا تو میں نے کہا جی میں امیر ضمیری ہوں، مجھے عامر ضمیری سمجھ لیں۔ کہتے اچھا چل خیر۔ میں نے کہا وہ کہاں گئی فیملی؟ کہتا جی میں نے اس کو کہا 2-3 دفعہ کہ آپ عامر ضمیر ہیں، انہوں نے کہا جی عامر ضمیر۔ تو جب میں نے تیسری دفعہ کہا کہ آپ IG کے بھائی ہیں تو وہ ڈر گیا، کہتا نہیں میں IG کا بھائی نہیں ہوں۔ تو پھر میں نے اسے ویسے بڑا لائٹر موڈ میں کہا کہ میں نے کہا یار وہ میری فیملی تو واپس کر دیں کہ جو میرے ساتھ تھی، تو وہ شرمندہ ہو گیا۔ بہرحال جب ہم باہر نکلے تو سب نے کہا کہ بڑی ہوا چل رہی ہے، ٹھنڈی ہوا چل رہی ہے، کراچی کی بڑی اچھی ہوا ہے۔ تو میں نے کہا یہ کراچی کا خاصہ ہے کہ جب ہوا چلتی رہتی ہے، خواہ ٹھنڈی ہو یا گرم، کبھی کبھی ٹھنڈی بھی چلتی ہے، کبھی کبھی گرم بھی چلتی ہے۔ ہماری خوش قسمتی ہے کہ یہ ٹھنڈی ہوا چل رہی ہے۔ تو یہ بات شاید وائس چانسلر ہمارے دوست NED یونیورسٹی تک بھی پہنچ گئی کہ کراچی کی ہوا بہت اچھی ہے. تو انہوں نے جو گاڑی ہمیں بھیجی وہاں پہ ریجنٹ پلازا میں, تو وہ بغیر AC والی بھیج دی اور ساری کھڑکیاں اس کی کھلی تھی, اور ہم وہ ساری ہوا جو کراچی کی تھی, وہ تھوڑی ٹھنڈی بھی تھی تھوڑی گرم بھی تھی, وہ ہم ہوا لیتے چلے آ رہے تھے. اچھا, وہ جو SSP صاحب تھے, انہوں نے ایک گاڑی ہمیں بھیج دی اپنے جو اسکاٹ کی گاڑی ہوتی ہے, جو آگے پروٹوکول کی گاڑی ہوتی ہے, جو ہوٹر والی گاڑی ہوتی ہے. تو اس نے گاڑی آگے لگا لی تاکہ راستہ بھی صاف ہمیں مل جائے اور تاکہ ہم جلدی بھی پہنچ جائیں. تو جو پیچھے گاڑی تھی وہ اتنے پرانے ماڈل کی تھی کہ اس کے لیے مشکل ہو گیا کہ اس کی سپیڈ کو ساتھ ساتھ مینٹین کر سکے, اور پرانی گاڑی بھی اتنی تھی کہ کچھ لوگوں نے سمجھا کہ یہ پولیس جا رہی ہے اور اس کے پیچھے 9 مئی کے ملزمان جا رہے ہیں. تو ہمیں 2-3 دفعہ راستے میں پاک فوج زندہ باد کے بھی نعرے لگانے پڑے. اس سے پہلے میں ایک بات بھول گیا ہوں کہ ہم ایک ہوٹل کو ہم نے سلیکٹ کرنے کی کوشش کی, تو جا کے دیکھا کہ یہ ہوٹل میں چلے جائیں, تو وہاں پہ لکھا ہوا تھا گھر کے باہر گھر جیسا ماحول. تو میرے ایک دوست تھے, میں نے کہا کہ یہ ہوٹل اچھا ہے, تو وہ ہاتھ جوڑ کے کہنے لگے بڑی مشکل سے IEP کے بہانے گھر سے باہر نکلے ہیں, تو یہاں بھی اگر گھر جیسا ماحول ملے گا تو خدا کے لیے اس ہوٹل میں نہیں ٹھہرنا. تو گھر کے باہر گھر جیسا ماحول تو کہیں ٹھہرنا, ہم کسی اچھے ہوٹل میں ٹھہرتے ہیں جہاں پہ کم از کم گھر جیسا ماحول تو نہ ہو. اب وہاں سے آ رہے تھے تو راستے میں ایک بورڈ ہم نے پڑھا, دیکھا لکھا, وہ تھا کہ وی ویلکم یو, اور نیچے لکھا تھا سائمہ. تو وہ ہمارے دوست کی وائف کا نام سائمہ تھا. کہتے میری وائف تو یہاں کراچی میں بھی میرا ساتھ نہیں چھوڑ رہی, میرا پیچھا کر رہی ہے اور یہاں پہ بھی ویلکم کر رہی ہے. بہرحال یہ تو وہ باتیں تھیں جو کراچی نے ہمیں ویلکم کی. میں یہاں پہ انجینئرنگ کمیونٹی کے حوالے سے اور سیکرٹری جنرل انسٹیٹیوشن انجینئر کے حوالے سے یہ بات کرنا چاہتا ہوں کہ انسٹیٹیوشن آف انجینئر کراچی سینٹر بہت خوش قسمت ہے کہ انہیں NED یونیورسٹی نے اپنا موت کا کنواں دیا ہوا ہے, جس میں انسٹیٹیوشن آف انجینئر کراچی اپنی موٹر سائیکل چلاتا رہتا ہے. کہ کوئی ایک پروگرام کرنا ہو, کوئی ایک فنکشن کرنا ہو, کوئی سیمینار کرنا ہو, کوئی کانفرنس کرنی ہو, تو ان کے سارے ہال اویلیبل ہوتے ہیں, ان کے سارے جتنے بھی آڈیٹوریم اویلیبل ہوتے ہیں, اور ان کے سب سے بڑی بات یہ ہے کہ آڈینس بھی اویلیبل ہوتے ہیں. ورنہ ہمیں لاہور میں یا اسلام آباد میں ہم ہر چیز تو ارینج کر لیتے ہیں, لیکن آڈینس ارینج کرنا آج کے دور میں بہت مشکل کام ہے. تو میں آپ کو یہ مبارکباد دیتا ہوں کہ خواہ وہ الیکٹریکل انجینئر کانفرنس ہو یا میکینیکل انجینئر کانفرنس ہو یا سول انجینئر کانفرنس ہو, تو آپ کی جو سکسیس ہے اس کے مقابلے میں کوئی بھی کبھی سینٹر نہیں پہنچ سکا. دوسری بات یہ ہے کہ جیسے آپ نے بات کی کہ آج بجلی کے بلوں کو آگ لگا رہے ہیں یا کے الیکٹرک کے لوگوں کو مار رہے ہیں, بات صرف یہ ہے کہ ہم نے اپنی قوم کو نہ تو کبھی حقیقت بتائی ہے اور نہ کبھی حقیقت کو برداشت کرنے کی قوت پیدا کی ہے. کبھی آج تک دیکھا کہ جب ٹماٹر 500 روپے کلو ہوں تو کبھی سبزی منڈی میں جا کے لوگوں نے کسی کو مارا ہو؟ کبھی آپ نے یہ کبھی دیکھا ہے کہ جب آٹا ان کی پہنچ سے باہر ہو تو کیا آٹا بیچنے والی ملوں کو کسی نے آگ لگائی ہو؟ کبھی نہیں دیکھا. لیکن ہم نے جب بجلی 50 روپے پر یونٹ جنریشن ہو اور ہم لوگوں کو 20 روپے پر یونٹ یا 10 روپے یونٹ بیچتے رہے ہوں, اور جب پھر 50 روپے بیچیں گے تو وہ بجلی کے بلوں کو آگ تو لگائیں گے. دنیا میں کہیں ایسا نہیں ہے کہ ایک چیز آپ جو پروڈکشن کاسٹ ہے اس سے نیچے آپ بیچنے شروع کر دیں اور ان کو وہ عادت ڈال دیں, اور ایک گھر میں آپ 4 AC لگا کے پھر کہیں کہ مجھے بل زیادہ آ رہا ہے, اور پھر آپ اس کو اس قیمت پہ لے جائیں جو اس کی اصل قیمت ہے, تو لوگ پھر بل تو جلائیں گے. لیکن بات صرف یہ ہے, چلیں آج ہم یہاں پہ بھی پہنچ گئے. ابھی 14 اگست کو جو لوگوں کے لیے تمغہ امتیاز، ستارہ امتیاز، حلال امتیاز ہم نے اناؤنس کیے ہیں، سینکڑوں ہیں، مختلف شعبہ ہے زندگی سے ہیں، انجینئرنگ سے بھی بہت ہیں، پروفیسرز بھی بڑے ہیں، گلوکار بھی بڑے ہیں، سیاستدان بھی بڑے ہیں. تو مجھے کسی نے ایک پوسٹ بھجوائی، چونکہ میں نے اپنا پورا تعارف نہیں کرایا، چونکہ میں پلاننگ کمیشن میں بھی ہوں، میں ہیڈ ہوں مانیٹرنگ اینڈ ایویلویشن کا. تمام پاکستان کے جو پروجیکٹس ہیں، ڈیولپمنٹ پروجیکٹس، ان کی مانیٹرنگ کا میں ہیڈ ہوں. تو میں سارے پروجیکٹس کو بھی دیکھتا ہوں پاکستان میں، اور جو اس کی جو پروجیکٹس کی منظوری ہے، اس کی جو سب سے ہائیسٹ فورم ہے CDWP میں، اس کا پچھلے 10 سال سے ممبر ہوں. تو میں نے یہ کہا، کسی نے مجھے یہ پوسٹ بھجوائی کہ ضمیر صاحب مجھے یہ بتائیں کہ کیا ان سارے جن کو آپ دے رہے ہیں، اس میں احسن اقبال صاحب اس کے پریزیڈنٹ چیئرمین تھے، جو کمیٹی نے ڈیسائیڈ کیا، انہوں نے کہا کوئی ایسا بندہ بھی ہے، کوئی انجینئر جس کو آپ نے حلال امتیاز دیا ہو اور اس نے بجلی جو کم خرچ پہ بنانے کی کوئی ایجاد کی ہو، کوئی ایسی ریسرچ کی ہو کہ جو بجلی کے نرخ کم کر سکے، جو پروڈکشن کاسٹ اس کی کم کر سکے، کوئی ایسا انجینئر بھی ہے؟ تو میرا جواب نہ میں تھا. کوئی ایسا بھی انجینئر ہے جس کو آپ نے ایوارڈ دیا ہو اور اس نے کوئی ایسی ایجاد کی ہو کہ جو آپ کی فیول کنزمپشن اس نے کم کی ہو، کسی آٹو موبائل کی یا کسی اور کی ہو؟ میرا جواب نہ میں تھا. میرا سر شرم سے جھک گیا. پھر میں نے وہ بھی دیکھا کہ پاکستان انجینئرنگ کونسل نے پچھلے 23 مارچ کو یا کسی اور دن سینکڑوں لوگوں کو لے گئے، انجینئرز کو لے گئے، گورنر ہاؤس صدر پاکستان کے پاس لے گئے، پریزیڈنسی میں لے گئے کہ جی اتنے انجینئرز ہیں جنہوں نے انجینئرنگ کے شعبے میں بہت نمایاں کردار ادا کیا ہے. تو وہ پریزیڈنٹ صاحب نے 8-10 لوگوں کو میڈل پہنائے اور پریزیڈنٹ صاحب تشریف لے گئے اپنے کمرے میں کہ باقی لوگوں کو آپ خود میڈل پہنا لیں. اور آخر پہ انہوں نے یہ کہا آف دی ریکارڈ کہ میں سوچ رہا ہوں کہ اگر اتنے لوگ اچھے میڈل والے ہیں تو پاکستان آج ترقی کیوں نہیں کر رہا ہے، پاکستان آج اس مقام پہ کیوں پہنچ گیا ہے. ہم نے پاکستان کی 5 یونیورسٹیز کے لیے، یہ پچھلے دور میں جو ختم ہوئی حکومت، 6.5 بلین روپیز رکھے ہیں، 6.5 بلین رکھے ہیں یونیورسٹیز کے لیے کہ اپنی جو لیبز ہیں اس کو اپ گریڈ کریں، اور اپ گریڈ اس طرح کریں کہ یہاں پہ ایسی ریسرچ ہو، ایسی آپ پروڈکٹس بنائیں کہ جن کو ہم ایکسپورٹ کر سکیں، جن سے ہم ڈالرز کما سکیں، پاکستان میں کوئی ڈالرز لا سکیں. تو میں آپ کو مبارکباد دیتا ہوں کہ اس میں نمبر 1 پہ جو یونیورسٹی ہے وہ آپ کی یونیورسٹی NED ہے. اور دوسرا میں آپ کو یقین دلاتا ہوں کہ آپ جو بھی ریسرچ کے پروگرام بنائیں گے، یہ ایک پروجیکٹ ہے. آپ جو انجینئرز ہیں، جو آپ طالب علم ہیں، آپ جو اسٹوڈنٹس ہیں، آپ جو بھی پروجیکٹ بنائیں جو انڈسٹری اور اکیڈیمیا لنکیج کے لیے ہو، جو اس قوم کے کام آ سکے، جو پاکستان کے کام آ سکے، جو اس کنٹری کے کام آ سکے، پورا پلاننگ کمیشن آپ کی ڈسپوزل پہ ہے، اس کے تمام فنڈز آپ کی ڈسپوزل پہ ہیں. کیونکہ ہمارا 1000 ارب روپے کا پورا ڈیولپمنٹ بجٹ ہے، لیکن اس میں بہت سارے ایسے پروجیکٹس ہیں جو میں خود کہتا ہوں کہ وہ سیاسی بنیادوں پہ بنائے گئے ہیں، اور بہت سارے ایسے پروجیکٹس ہیں شاید اس میں وہ انجینئرنگ انوالو نہ ہو جو پاکستان کو ترقی کی شاہراہ پہ گامزن کر سکے. لیکن میں آپ کو یقین دلاتا ہوں کہ آپ کا کوئی ایسا پروگرام، کوئی ایسا جو پروجیکٹ ہے، وہ انشاءاللہ وہ انفنڈڈ نہیں رہے گا. پاکستان زندہ باد.
Thank you, sir, for your valuable words. Now I would like to request Engineer Farhat Adil, President, Institution of Engineers, Pakistan, to deliver his address.
بسم اللہ الرحمن الرحیم. ڈاکٹر سروش لوری صاحب، امیر ضمیر صاحب، میاں عبدالحق صاحب، फरीदा जावेद साहिबा, सोहेल बशीर साहब, आसिम मुर्तजा साहब और दूसरे तमाम साथी जो बाहर से तशरीफ लाए। अस्सलाम वालेकुम। असल में बहुत ऑलरेडी हम लोग लेट हो गए, 4:30 बजे में प्रोग्राम ये खत्म करना था, क्योंकि इसके साथ हमारी इंस्टीट्यूशन इंजीनियर्स में आज बहुत मीटिंग्स आज भी हैं, फिर कल सुबह सेंट्रल काउंसिल की मीटिंग भी है, एजीएम भी है, तो मैं बहुत ज्यादा बिल्कुल वक्त नहीं लूंगा। मैं सिर्फ बहुत शुक्रिया अदा करना चाहता हूँ आप सबका कि आप लोग आए और आपने यहाँ पे इलेक्ट्रिकल इंजीनियरिंग कॉन्फ्रेंस में शिरकत की। और बहुत खुशी की बात है, जैसा डॉक्टर साद कादिर साहब ने बताया कि 31-32 पेपर्स पढ़े गए यहाँ पे, और उसके अलावा 3 फॉरेन की नोट एड्रेस भी पढ़े गए। तो बस यही है जो कल भी मैंने जैसे कहा था कि इन तमाम चीज़ों का यही चीज़ है कि हम इस पे ऐसी चीज़ें अमल करें जिसपे जो अमल के काबिल हों, और जो भी रिकमेंडेशन हो कॉन्फ्रेंस की वो मुताल्लिका लोगों को पहुंचा दी जाएं। मैं बिल्कुल ज़्यादा वक्त नहीं लूंगा। बहुत आप सबका शुक्रिया। अस्सलाम वालेकुम।
Thank you, sir, for your wise words. Now it is my humble duty to request Engineer Professor Dr. Sarosh Hashmat Lodi, Honorable Vice Chancellor, NED University of Engineering and Technology, to please come to address the audience.
Bismillahirrahmanirrahim. Respected Farad Adil Saab, Amir Zamir Saab, Sohail Bashir Saab, Farooq Arabi Saab was here. Anyway, respected fellow engineers and students, Assalamu alaikum. I was sitting beside Amir Zamir Saab and I asked him about the advantages and disadvantages of DC and EC currents. And the reason was that I was still a very serious mental block when it comes to electricity. Never understood this thing, even though I'm a beneficiary, but I want to stay away from electric current because whether it is DC or EC, it gives you the shock of your life. So that's why I was a little reluctant. To come to this conference, especially knowing that a very big delegation from the Institution of Engineers is coming here, and I thought I wanted to give them a wonderful experience and remind them of their school days. So that's why I've sent a school van. So and I'm so happy that you have learned and enjoyed your school days. I'm so happy and delighted to know the support from Planning Commission of Pakistan. I'm a big fan of Hassan Iqbal Saab as a person who's a policy maker and who has a very soft heart and true belief in the engineers of Pakistan. And it was only because of his efforts that the 5 universities in Pakistan got a massive grant of about 6.5 billion rupees to strengthen their laboratories. But it was so happy to see that the industry and the academia and the government are licensing and some of the projects have realized. Sir, Pakistan's one of the biggest, Pakistan is, mashallah, huge number of problems. But one of the biggest problem is that we tell everybody what the problem is. How many times we've really tried to find a solution to our problems? And I think it is engineers, by inherent engineering professionals' responsibility to find solutions to the problems. And Pakistan's circular debt is one of the biggest reasons is our energy sector. It is bleeding and it is continuously bleeding. And unless we pluck this bleeding, the economic conditions probably will never ever improve. Amir Zamir Saab has made an offer, and I'm going to make a suggestion, and I'll request the President IEP to take the lead. Any university in its entire system is there to support. Let's pitch in a project, let's pitch in a request of a 1 billion rupees of endowment for University Industry Liaison, in which I have a very clear picture of what needs to be done. It is going to be an endowment fund. Nobody's going to touch the capital, but that will be solely used for development of engineering sector, especially reverse engineering in the country. and especially the power sector, especially find out the ways and means and build capacity to reduce our circular debt. To my understanding, it is not as big a problem as it appears. So if I volunteer myself to submit a develop a PC1, we should be controlled by IEP. We should have a proper board, proper management system, proper mechanism to provide relief to the energy sector. We have always been talking about industrial liaison. As long as I remember, there is a talk about industrial liaison, but I haven't seen liaison happening in real time and in real life. It has always been lip service. We have started a few initiatives. It'll take time before they start bearing the fruits. But I'm sure that if this could be materialized, obviously the PSDP has been finalized for this year. So we must be targeting a 24-25 financial year. But if we start doing it today, and I'm sure that we will be able to create, and there is a history in the past where the Planning Commission has endowed money for the Ministry of Science and Technology, for Sultan Qaboos Endowment Fund. We are the beneficiary of those endowment funds. The same thing could be repeated again. So we're not going to reinvent the wheel. The reason I spoke intentionally in English, and trust me, my Urdu is not bad, is because Amir Zamir Saab and Sohail Bashir Saab together were trying to convert it into an AC current. And then Amir Zamir Saab told me that AC current gives a lot of loss in long-term distance traveling. So there must be a DC current, That's why it has to be in English, because it started in English. With this, I thank all of you, especially Institution of Engineers Pakistan and Karachi chapter especially, because we have forged a relationship which has really provided a lot of platform apart from providing the infrastructure and the audience. So it's a little more than this, sir. Thank you very much.
Thank you, sir, for your inspirational words and your esteemed presence here. Now I would like to request Engineer Sohail Bashir, Chairman, Institution of Engineer Pakistan, Karachi Center, for the announcement of Best Paper and Best Poster Award.
Thank you. Before I announce the best poster and best paper presented during this conference, just wanted to highlight one more thing, that the relationship between the NED University and IEP, previously in the previous years, we used to have 3 international conferences every year: electrical engineering, mechanical engineering, civil engineering, and the 4th one used to be a workshop, and now it's a regular conference on occupational health, safety, and environment. From last year, we expanded our agenda, and now from last year, we had started 7 international conferences. And out of those 7 conferences, already this year, we have completed 3 conferences. The first one was the Mechanical Engineering Conference, which was held in February this year. Then the International Biomedical and Digital Health Conference. Again, this came out of COVID. And during the COVID, there was a lot of initiatives taken in the digital health. So we thought it fit that we should have a digital health conference with biomedical engineering. That was held last week. This week, we had this International Electrical Engineering Conference. And next week, on 2nd of September, on Saturday, at Movenpick Hotel, we are going to have International Occupational Health and Safety Environment Conference, where these conferences are mostly tilted towards academics and industry, but there in the occupational health and safety, the total tilt is toward the industry. So all the big industries come, the multinational industry come, and they share their experiences so that people come to know what are the best practices of occupational health and safety so that they can adopt it. Followed by that, we'll have International Civil Engineering Conference in November, Advanced Materials Conference in December, and then also on the UN sustainability, the 17 SDGs. So last year we had a conference with our international partners, in which the US aid was there, United Nations UNDP was there, government of Pakistan was there, Sindh government sponsored that particular conference that was held in Marriott. Inshallah, this year also we'll try to continue that conference. It was a big conference where I think around 20 international organizations participated in that conference. So we are there to do this. Now, coming back to this, in this particular conference, there were 15 posters presented, and the best poster award goes to the poster. The topic was multi-objective ABC logarithm to optimally place UPFC and parameter settings for transmission efficiency enhancement. And the authors are Muzammil and Rajpal. So give them a big hand. Muzammil and Rajpal are here. They are from NED University. For the best paper oral presentation, we had around 35 papers. Out of those 35 papers, 3 papers have come very, 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 very close. And to judge from those 3 papers, which is the best, almost there is a tie between these all 3 papers. But then we preferred a paper which has been presented by a university from out of Karachi, out of Sindh province. That's the hospitality plus the best award. So I'll just give you the 3 papers which were very close. The one is the comparative analysis of design parameters for modern radio frequency CMOS. Author Mohammad Uwais Akhtar from Beria University. Give him a big hand. Beria University, from Beria University. He's from Karachi, Beria University, Karachi. This is the one of the best. The second one is the solar impedance forecasting using deep learning techniques, and the author is Moeed Alam from NED University. And the winner, actually it is customary to give one. The winner is design of dual-based microstrip patch antenna for wireless local area network application. Author is Mohammad Zahid from UT Texela. शील्ड लेकर आना यार, एक शील्ड लेकर आना, एक शील्ड ले। प्रेसिडेंट साहब कह रहे हैं और अमीर साहब ने भी कहा कि वो जो बाकी दोनों हैं उनको भी शील्ड्स दे दें। तो मैं फोटोग्राफी के लिए शील्ड है, हम इनको शील्ड्स प्रेजेंट करेंगे और सर्टिफिकेट भी देंगे। तो अगर ये उवैस अख्तर बहरिया यूनिवर्सिटी के यहाँ पे मौजूद हैं और मोईद आलम NED यूनिवर्सिटी, आ जाए मोईद। फरज साहब ठीक हो गया सर? फरज साहब ठीक है, थैंक यू सर, थैंक यू। फरज साहब ने, प्रेसिडेंट साहब ने कहा कि जो दोनों हैं इनको भी आप शील्ड्स दें, तो थैंक यू वेरी मच, प्लीज।
Thank you, sir. Ladies and gentlemen, it's time for the distribution of mementos. I would like to call Engineer Professor Dr. Sarosh Hashmat Lodi, Vice Chancellor NED UET, Engineer Suhail Bashir, Chairman IEP Karachi Center, Engineer Professor Dr. Saad Ahmed Qazi, Dean Electrical and Computer Engineering NED UET and Convener IEEC 2023, Engineer Muhammad Farooq Arbi, Secretary IEP Karachi Center, Engineer Farhad Adil, President Institution of Engineers Pakistan, for the presentation of awards and mementos. Now I request Engineer Professor Dr. Sarosh Hashmat Lodi, Vice Chancellor NED UET, to please receive memento from Engineer Suhail Bashir, Chairman IEP Karachi Center. Now I would like to request Mr. Azim Anwar, who has delivered a keynote speech on applications of machine vision technology in local industry, to please come to receive memento. Now I would like to request Engineer Farida Javed, Vice President Electrical and Allied IEP, to please receive memento. Now I would like to request Engineer Dr. Mohammad Ashraf Sheikh, Vice President Chemical and Allied IEP, to please come to receive memento. Now I would like to request Engineer Ayaz Mirza, Vice President Mechanical and Allied IEP, to please receive memento.
कराची से तकलीफ लाए न्यू कराची न्यू कराची एक बोतल में 3 जिन बिठा है.
Now I would like to request Engineer Amir Zamir Ahmed Khan, Secretary General IEP, to please come to receive memento. Now I would like to request Engineer Mia Abdul Haq, Chairman IEP Lahore Center, to please come to receive memento. Now I would like to request Engineer Dr. Zakaullah Khan, Chairman IEP Peshawar Center, to please come to receive memento. Now I would like to request Engineer Muhammad Afzal Gorai, Secretary IEP Lahore Center, to please come to receive memento. Now I would like to request Dr. Muhammad Mohsin Aman, Co-Chairman Department of Electrical Engineering, NED University, to please come to receive memento. जी उनके Now I would like to request Dr. Ataullah Khibrani, representative of BUET Khuzdar, to please come to receive memento. Now I would like to request Professor Dr. Abdul Sattar San, representative of Quest Nawabshah, to please come to receive memento. Now I would like to request Engineer Dr. Krishan Lal, University's Coordination Secretary, IEEC 2023, to please come to receive memento. Now I would like to request Engineer Sharik Sheikh, Program and Technical Team Member, IEEC 2023, to please come to receive memento. Now I would like to request Engineer Dr. Abdullah Muni, Program and Technical Team Member, IEEC 2023, to please come to receive memento. Now I would like to request Engineer Adnan, Program and Technical Team Member, IEEC 2023, to please come to receive memento. Now I would like to request Engineer Syed Mohammad Zahid, IT Support, IEEC 2023, to please come to receive memento. Now I would like to request Engineer Muhammad Hamaduddin to please come and receive memento. Now I would like to request Dr. Abdul Ghani Abro, Conference Secretary, IEEC 2023, to please come to receive memento. Now I would like to request Engineer Asif Zahoor to please come to receive memento. Now I would like to request Engineer Uruj Faiz to please come to receive memento. इनके बाद एक और सर एक मिनट मैं अभी एक मिनट नहीं सर अभी एक मिनट. Now I would like to request Engineer Hafsa Wahid to please come to receive memento.
कोई है?
सर मैं
हाँ मुझे पता है.
कल भी इनॉग्रल सेशन में भी इन्होंने बड़ी मेहनत की और आज भी पूरा सुबह से मेहनत कर रही हैं नाजिया नवीद। तो
Now I would like to request Engineer Ayaz Mirza, Vice President, Mechanical and Allied Institution of Engineers, Pakistan, to please come to deliver vote of thanks.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. محترم سروش لودھی صاحب وائس چانسلر NED یونیورسٹی، محترم فرد عادل صاحب پریزیڈنٹ انسٹیٹیوشن آف انجینئرز، محترم امیر ضمیر صاحب سیکرٹری جنرل IP، سہیل بشیر صاحب، ہمارے فاروق عربی صاحب، عاصم مرتضیٰ صاحب، اور جو ہمارے میاں آپ صاحب اور جتنے بھی لوگ ہمارے باہر سے تشریف لائے ہیں، جو وائس پریزیڈنٹس ہمارے ہیں، اشرف صاحب ہیں، فریدہ جاوید صاحبہ ہیں، چغتائی صاحب ہیں، جو مجھے نظر آ رہے ہیں، فاروق عربی صاحب، السلام علیکم۔ یہ بہت آئی ایم آنرڈ کہ IP نے مجھے ایک فارمل ووٹ آف تھینکس کے لیے جو ہے نا یہ آنر دیا ہے، حالانکہ مجھ سے پہلے جتنے بھی لوگ آئے ہیں وہ سب شکریہ ادا کر کے جاتے رہے، ہر ایک کا شکریہ ادا کرتے رہے، لیکن بہرحال اس میں سب سے پہلے کہوں گا کہ یہ جو 2 روزہ کانفرنس تھی یہ بڑی فروٹفل رہی، اور اس میں جو مختلف، ایک تو پچھلے سالوں کے مقابلے میں اس سال جو ہماری کولیبریٹنگ یونیورسٹیز تھیں، جیسے کہ ڈاکٹر سعد قاضی نے بتایا کہ 16 کے قریب جو ہے نا انسٹیٹیوشن اور دوسری انجینئرنگ یونیورسٹیز نے اس میں کولیبریٹ کیا، اسی طرح سے تو اس کی وجہ سے جو ہمارے ایونیوز ہیں ریسرچ کے، جو ہماری پریکٹسز ہیں، جو نیو ڈیولپمنٹس ہیں، وہ بھی بہت کا جو ہاریزن ہے وہ اس کانفرنس میں بہت بڑھ گیا، اور انشاءاللہ یہ مزید بڑھتا رہے گا، اور میں سمجھتا ہوں کہ میں ان تمام کولیبریٹنگ پارٹنرز کا بالخصوص شکریہ ادا کرتا ہوں کہ انہوں نے بڑی محنت اس میں کی اور اپنی تمام جو ان کی ریسرچ تھیں ان سب کو جو ہے نا ہمارے ساتھ شیئر کیا۔ اس کے علاوہ میں جو آرگنائزنگ کمیٹی ہے اس کا بہت شکر گزار ہوں۔ اس کے علاوہ جناب میں NED یونیورسٹی اور IP کا جو ایک کولیبریشن چل رہا ہے، اس میرج کو 10 سال سے زیادہ ہو گئے ہیں اور ماشاءاللہ بڑی کامیابی سے چل رہی ہے، اور اس کے آؤٹ کمنگز بھی آپ نے دیکھا کہ بڑھتے جا رہے ہیں۔ جو پہلے 3 یونیورسٹیز تھیں وہ اس میں بھی اضافہ ہوتا جا رہا ہے، اور اس طرح سے انشاءاللہ یہ ریسرچ بیس بھی بہت ساری ہم چیزیں، اور بھی بہت ساری چیزیں سہیل بشیر صاحب نے کچھ بتائی، آپ کو نئی کانفرنس ہو رہی ہیں، اس کے علاوہ بھی بہت ساری چیزیں ہیں کہ جو انڈر کنسیڈریشن ہیں، اور جیسے جیسے وہ تھوڑی سی ایک میٹیریلائز ہونے کی نزدیک پہنچیں گی تو آپ کو پتہ چلیں گے۔ تمام آڈینس کا جنہوں نے 2 دن تک یہاں بیٹھے رہے بہت شکر گزار ہوں، تمام آرگنائزنگ کمیٹی کا، NED کے اسٹاف کا، اور ہمارے IP کے اسٹاف کا، سیکریٹریٹ کا، اور اس میں بالخصوص آپ نے دیکھا ہوگا سہیل بشیر صاحب یہاں تشریف لائے تو ان کے دونوں ہاتھوں پہ پلاسٹر چڑھے ہوئے، لیکن اس کے باوجود بھی وہ جو ہے نا بایو میڈیکل انہوں نے بڑی مشکل سے ان کی مس ہوئی ہے، اس میں بھی یہ آن لائن آ گئے تھے، لیکن یہ ان کا ایک جو ایک جذبہ ہے نا، وہ اس جذبے کی وجہ سے یہ ساری چیزوں کے پیچھے، باقی چیزیں تو ہو ہی جاتی ہیں لیکن ایک بندہ کوئی ایک موٹیویٹر ہونا چاہیے، ایک جو ہے نا وہ موٹیویٹنگ فورس جو ہے نا وہ ہمارے سہیل بشیر صاحب ہیں، ان کے بالخصوص تعلیم۔ انشاءاللہ یہ سلسلہ چلتا رہے گا، اور جو ریکمنڈیشنز بھی ہیں اور نئے ایونیوز بنتے رہیں گے، اور انشاءاللہ سب کا بہت بہت شکریہ، جو ہمارے میڈیا پارٹنر ہیں اور جو دوسرے ہمارے اسٹاف ہیں، سب بہت بہت شکریہ۔ تھینک یو ویری مچ۔
Thank you very much, sir. Ladies and gentlemen, I thank you all once again for your participation. With this, the closing session is now concluded.
मेरा ख्याल है सरोज साहब आपने लास्ट कॉन्फ्रेंस में एक बात की थी और इस वक्त हमारे काउंसिल के सारे मेंबर्स भी इंशाल्लाह हम कल सेंट्रल काउंसिल में बात भी कर लेंगे कि आईपी में भी जो आईपी का एक सब सेंटर एनईडी यूनिवर्सिटी में भी बनाया जाए, तो उसकी इंशाल्लाह ताला हम सेंट्रल काउंसिल से अप्रूवल भी ले लेंगे। तो इंशाल्लाह अप्रूवल के बाद फिर फॉर्मली एक एनईडी यूनिवर्सिटी के अंदर स्टूडेंट चैप्टर आईपी का जो है ना वो इंशाल्लाह ताला एस्टैब्लिश करेंगे।
You all are requested to gather here for group photo.
ये मेरा कैमरा देखते रहना, क्या करो सर, थोड़ा सा कुछ हो जाएगा। जी जी थैंक यू सर, थैंक यू।
You all are requested to proceed to the classroom of Civil Engineering Department at first floor for refreshment. Thank you very much.